Good morning, everyone. Excellencies, dignitaries, guests, teachers, and all students over online and offline. We are much delighted to offer a hearty welcome to everyone gathered over here. We, the Department of Statistics, St. Thomas College Autonomous Thrissur, blissfully invite one and all present here for the two-day national webinar on the recent developments in statistics and probability. St. Thomas College, Thrissur is one of the leading academic institutions in the higher education sector of Kerala since 1919. It has a long and proud tradition of excellence in training, teaching, and research in many academic disciplines of science, arts, commerce, and humanities. The Department of Statistics was established in the year 1984 and the MSc course in statistics commenced in the same year with operation research, numerical mathematics and computer programming as optional subjects. Department was elevated as research center of the Calicut University in the year 2013. The department offers certificate course in statistics for UG and certificate course in statistical data analysis for PG students. The aim of this webinar is to bring together mathematics and statistics research scholars from different parts of the country for exchange of ideas and latest developments through plenary lectures, invited talks, and paper presentations. The two-day national webinar will provide a platform for interaction of the young statisticians and researchers with a galaxy of eminent mathematicians and statisticians by exchange views on latest developments in various fields of statistics and probability. Let's begin the formal session by invoking the God Almighty. I invite Kavya KU for the prayer.
ധന്യമീ ജന്മം മലർച്ചെടിത്തൈയൊന്നു നട്ടു നനയ്ക്കാനാകുമെങ്കിൽ നട്ടു നനച്ചു വളർത്തിയതിലൊരു പൂ വിരിയിക്കാനാകുമെങ്കിൽ പിന്നെ ആ പൂവിൻ്റെ ചാരത്തിരുന്നതിൻ ഗന്ധം നുകരാനാകുമെങ്കിൽ പൂവിൻ്റെ സൗരഭം പോലെ ഈ ലോകത്ത് നന്മകൾ മാത്രം പരത്തുമെങ്കിൽ നന്മകൾ മാത്രം പരത്തുമെങ്കിൽ.
Thank you for the soothing prayer, Kavya. I invite Dr. Anushree MR, Assistant Professor, Department of Statistics, St. Thomas College, Thrissur, to welcome the gathering.
Greetings to one and all. Seminars are organized and conducted to gain insight and information that would remain effective in their life, exercises, and work. It's a matter of great pleasure that Department of Statistics, St. Thomas College, Thrissur, is organizing a two-day national webinar on recent developments in statistics and probability jointly with IQAC. The rapid development of statistics and its applications in diverse fields have made the topic of the webinar very significant. We have various eminent speakers on both the days. I am sure everyone will benefit from each and every session. A respected manager, His Excellency Mar Tony Neelangavil, St. Thomas College, Thrissur, the Executive Manager, Reverend Father Verghese Kuttur, St. Thomas College, Thrissur, in their absentia, we extend a warm welcome. First of all, I extend a warm welcome to our principal, Dr. Joy KL. Our principal has always supported us in all the endeavors of the department. Next, I would like to welcome our beloved head of the department, Dr. V.M. Chako, who is a constant source of inspiration to the faculty as well as students in the department. Next, I would like to welcome the Vice Principal, Dr. Joby Thomas, who gives us constant encouragement and guidance in all our activities, especially those related to research. I would also like to welcome our Vice Principal, Reverend Dr. Martin K., who is already ready to support us in all our ventures with a strong sense of direction and vision. An enthusiastic and cordial welcome is extended to various speakers: Dr. P.G. Sankaran, the PVC of Cochin University of Science and Technology; Dr. K. Muralidharan, Professor, Department of Statistics, Maharaja, Sayajirao University, Baroda; Dr. Satheesh Kumar, Professor and Head, Department of Statistics, University of Kerala, Trivandrum; Dr. S.M. Sunoj, Professor, Cochin University of Science and Technology. Finally, I am very happy to welcome my colleagues, students, teachers, researchers, and the participants for the two-day webinar. I would like to express my heartfelt gratitude to all of you who sincerely committed to this event to make it as a success. This event would have been impossible without the support of each and everyone present here. Thank you, one and all.
Thank you so much, ma'am. Now I invite Dr. V.M. Chacko, Associate Professor, Head, Department of Statistics, St.Thomas College, Autonomous Thrissur, to deliver the presidential address.
A very good morning to all. Dear Dr. Anusri, the coordinator of the national webinar, dear Dr. Joy KL, principal of the college, Dr. P.G. Sankaran, professor and pro-vice chancellor of Cochin University of Science and Technology, vice principals, Dr. Martin Columbrath, Dr. Joby Thomas K., heads of the departments, and Dr. Theo Jensen, former principal of our college, dear faculty members, joint coordinator of the seminar, Ms. Ashlyn Matthew, research scholars, students, and participants from various institutions. Statistics and probability studies become an inevitable part of every discipline, including social science, computational studies, data science, big data analytics, etc. As a science, statistics provide powerful tool for the analysis and interpretation of every step of research. But a large interest in the combined subject statistics and computer science, namely data science, became more interesting recently. In India, a few universities started courses in data science. So it is an opportunity for us to discuss key points of new approaches in statistics and probability. The natural question would be how we should inculcate responsible use of statistics in data analysis, research, industry, science, social science, etc. So in this context, we need to understand recent developments in statistical approaches in probability and statistics. So we have experts from various famous institutions, like from Cochin University of Science and Technology, we have Professor P.G. Sankaran. He's the Pro-Vice Chancellor. Currently, he's the Pro-Vice Chancellor. And Dr. S.M. Sunoj, Professor, Department of Statistics, Cochin University of Science and Technology. He is the alumni of our department. And Dr. Satheesh Kumar, Professor and Head, Department of Statistics, University of Kerala. And Dr. K. Muralidharan, Professor, Department of Statistics and of MS University, Baroda. And during this COVID-19 period, I feel it was the right time to shower streams of knowledge to the students, researchers, faculty members in the area of probability and statistics through online platform. Our beloved manager, His Excellency Tony Nilangavil, Auxiliary Bishop of Thrissur, Archdiocese, agreed to join the seminar, but due to his busy schedule, he informed that he cannot join the program from the beginning. The principal, Dr. Joy Kale, gives us all support for the program, and he will inaugurate our national seminar. To our eminent speakers, delegates, faculty members of our department, college, outside college, retired faculty members, research scholars, students from various institutions, I wish you a very warm welcome to the seminar, and let this seminar become a storm of inspiration to grow further in the research in the area of probability and statistics. So let this event motivate you further. Thank you very much.
Thank you so much, sir. Now I would like to invite Dr. Joy KL, Principal, St. Thomas College, Thrissur, to inaugurate the webinar and to deliver the inaugural speech.
Joy sir, please unmute your mic. Please unmute your mic.
Okay. Very warm good morning to all. Vice Principal Dr. Joby Thomas K, Reverend Dr. Martin Columbrath, Dr. V.M. Chacko, Head of the Department, eminent professors from various universities, Dr. Anusri M.R., the convener of this national webinar, faculty members, research scholars, and dear students. It adds to the pleasure of our college as we learn that the Department of Statistics organizes a national webinar on the recent developments in statistics and probability. As we know, statistics is a science relevant in the collection, analysis, interpretation, and display of data. That is, the science of statistics has got a say in all branches and aspects of knowledge. And probability has become an indispensable tool in social and natural sciences like statistics, mathematics, physics, finance, artificial intelligence, linguistics, computer science, and application, etc. We can find the role of probability being significant in all walk of life and all branches of knowledge. And so, it is most suited to have this brainstorming session of 2 days, for we expect to have a more comprehensive, more elaborate, and advanced vision of all branches of understandings. Let me make use of this opportunity to congratulate and thank Dr. V.M. Chacko, the head of the department, Dr. Anusri, the coordinator of this today national webinar, and all the colleagues in the department on behalf of the management and administration of the college. Endeavors like this will render chances for excellence to our students. Wishing one and all the best, let me declare, with your permission, the webinar on recent developments in statistics and probability open. Thank you. Thank you very much.
Thank you so much, sir, for sharing your thoughts. Now, I welcome our vice principals to felicitate the gathering. I would like to welcome Dr. Joby Thomas K, Vice Principal, St. Thomas College Autonomous Thrissur, for the felicitation.
Respected Principal Dr. KL Joy, who has inaugurated this national webinar. The President of this session and the Head of the Department of Statistics, Dr. V.M. Chacko. The coordinator of this program, Dr. Anusri M.R., as well as Mr. Ashlyn Matthew. Vice Principal Reverend Dr. Martin Columbrath. Other dignitaries in this program. Faculty members, especially of the Department of Statistics at St. Thomas College. Research scholars, postgraduate students, and ladies and gentlemen. At the outset, I would like to congratulate the Department of Statistics, Dr. V.M. Chacko, the head of the department, and his team for arranging a two-day national webinar on recent developments in statistics and probability. Also, I would like to thank the organizers for giving me a chance to address in this inaugural ceremony. As far as statistics is concerned, it covers all research. It can extend its wing all parts of the research, either in the science, arts, humanities, everywhere. There is a role for statisticians. And here in our institution also, this department is extending this facility to the public by sharing their expertise in the field of statistics. As you are aware, many researchers are approaching this department and the faculty members for completing their PhD programs and other research works to compile the data, to analyze the data, and to present the data. In these three areas, this department is serving their best, and the institution is really proud of this department and the faculty members for sharing their knowledge to the public and the researchers. In this context, this seminar is a platform to inculcate the spirit of research, the spirit of data analysis, the spirit of compilation of data, and all these things, especially by having enlightenment into the field of statistics as well as probability area. Once again, I congratulate this department. I wish all success to this program. I'm sure that these sessions, the 4 sessions arranged in this webinar, will be helpful and beneficial for the participants and delegates to pursue good research in the field of statistics. I especially acknowledge the consent of 4 eminent resource persons. First of all, Dr. P.G. Sankaran, the PVC of CUSAT, as well as Dr. K. Muralidharan from MSU Baroda, as well as Dr. C. Satheesh Kumar from University of Kerala, and Dr. S.M. Sunoj from CUSAT. On behalf of the institution, I especially acknowledge their willingness to share their knowledge in this webinar, and I hope this will help all the participants, delegates, to have more awareness in the area of statistics and probability and to pursue quality research in future. Thank you, one and all. Thank you.
Thank you so much, sir. Now I would like to welcome Reverend Dr. Martin Columbrath, Vice Principal, St. Thomas College Autonomous, Thrissur, for the felicitation.
A warm good morning to one and all. Respected Principal, Vice Principal Dr. St.Thomas, HOD Chakosa, and other dignitaries and dear students. A scholar is considered to be one who updates with the recent developments in his own area. So the webinar proposed by the Department of Statistics, two-day webinar on recent developments in statistics and probability is very relevant. And this department has been giving a great service to not only to the college but also to the public outside in conducting the various kinds of surveys and all. And data has become so important these days in the COVID and post-COVID age. Data analysis has become so, it's a very important factor. So I hope that this webinar will be a brainstorming sessions, and we look at the resource persons. Now it's going to be a wonderful event. Wishing all the best on the part of the management. I conclude. Thank you. Wishing you all the best. Thank you so much.
Thank you so much, Father. Here we come to the close of our inaugural program. I invite Ms. Ashlyn Matthew PM, Professor, Department of Statistics, St. Thomas College, Thrissur, to propose the vote of thanks.
Good morning, one and all. Respected Principal, all dignitaries, and dear participants. It's a pride moment for me to be before you as a coordinator of this webinar. I take this opportunity to thank Dr. V.M. Chaku, head the Department of Statistics, who chaired this session. He's the brain behind this webinar. Thank you, Chaku, sir. Dr. Joy Kale, our principal, was kind enough to inaugurate this webinar, and he always promotes these kinds of academic activities, even at this time of pandemic. Thank you, dear principal. Dr. Joby Thomas K., the vice principal, was kind enough to accept our invitation to felicitate this webinar. He's always a good friend and a guide of our department. Thank you, Joby, sir. Now, I express my sincere thanks to Father Martin Columbrath, our Vice Principal and Bursar, for his valuable advice and guidance. Thank you, Father. I also express my sincere gratitude to all the resource persons, paper presenters, chairpersons of the technical academic session, and all participants of the webinar. I take this opportunity to thank my fellow coordinator, Dr. Anushree M.R., and all my colleagues for the guidance and support in organizing this webinar. I express my gratitude to the management, the IQAC, and all the teaching and non-teaching staff of our college, and our dear students for their cooperation and support. Last but not the least, I thank and seek prayers from the God Almighty. Thank you all.
Thank you so much, ma'am. Here we come to an end of our inaugural session. It is our privilege to have you all online and offline with us. Next, we will be having our technical session. The session will be chaired by Dr. P.O. Jensen, Principal, Sahrdaya College of Advanced Studies, Kodagara. If you have any queries or comments, you can type it on the chat box at the end of the session. Dr. P.O. Jensen is a former principal of St.Thomas College, Thrissur, and he was an associate professor of Department of Statistics. Sir, I welcome you to chair the session. Over to you.
I think you can hear me. Hello, good morning. Can you hear me now?
Yes, sure, sir.
Okay, thank you. We have two invited talks in this session, one by Dr. P.G. Sankaran, Pro-Vice Chancellor of Cochin University of Science and Technology, and second one is Professor S.M. Sunoj, Professor of Department of Statistics, Cochin University of Science and Technology. First talk, it's on quantile modeling. We have Dr. P.G. Sankaran, Pro-Vice Chancellor, Cochin University of Science and Technology, Cochin. Dr. P.G. Sankaran, he's one of my very close friends, and he's a member of International Statistical Association in Netherlands, American Mathematical Society, Institute of Mathematical Statistics, International Indian Statistical Association, and the International Society for Business and Industrial Statistics, US. He started his career as a statistician in the Spices Board in 1993 and later joined Marthoma College, Perumbavoor as a lecturer in 1995. He was appointed as lecturer in statistics at CUSAT in 1997. From 2017 onwards, 18 onwards, he is serving as Pro-Vice Chancellor of Cochin University of Science and Technology. He won the Young Researcher Award of International Indian Statistical Association, Boys Cast Fellowship of DSTA, and many more. He has 135 research articles, graded more than 10 research students for their PhD. Now, quantile modeling has received increasing attention in recent years and applied to wide areas such as investment, finance, economics, medicine, and engineering. Let us listen on this subject, quantile modeling, by our resource person, Dr. P.G. Sankaran. I think altogether there is 1 hour for this talk. So we can make it some 40 minutes presentation, and after that we can make some discussion and comments. Is it okay, Dr. Sankaran?
Okay.
Okay. So
Okay.
you can start your talk, please.
Okay, good morning. Good morning. Good morning.
Good morning.
Okay. First of all, I thank the organizers for inviting me to present some of the ideas on quantile modeling. I also thank Dr. Denson for the kind introduction, and thank Ashlyn for the time management. This is a perfect time, 10:30, we begin the technical session. Okay, so as mentioned earlier, the title of the talk is Quantile Modeling. The roadmap of the talk is the following. I give a brief introduction of this subject and relevance of the subject, and study the properties of this particular quantile functions. We also study the moments. Also, we give some important quantile function models which are available in literature. Then the next question is how to estimate the parameters of the model, or what are the inference procedures available for the quantile function models. Then we consider the applications. In this session, I'm going to consider the quantile based reliability analysis, how these quantile functions are useful in reliability theory. Then we give some data analysis, also consider some interdisciplinary concepts based on quantile functions, and finally give some references which includes latest one also. As you know, traditionally, any natural phenomena which has the uncertainty is represented by the probability distribution. Traditionally, the probability distribution is represented by either by distribution function, that is cumulative distribution function, fx, that is the probability of x less than or equal to x, or by the derivative of this, that the probability density function in the continuous case, or the probability mass function in the discrete case. Then there is an alternate approach, which is based on the inverse of the distribution function, that is the quantile function, which is defined by q equal to f inverse u, that is infimum of x, such that fx greater than or equal to u. That means if you have a distribution function fx in the continuous case, and concentrating on continuous case here, so distribution function fx equal to probability of x less than or equal to x, then one can transform or find an invertible one of this distribution function, which is represented by qu, which is generally defined by infimum of x, such that fx greater than or equal to u. Okay, so in usual sense, we have an x-axis, the points, the data points or the x values, and y-axis the fx, and we concentrate on the values on y-axis, which lies between 0 and 1. But in quantile setup, we concentrate on values on x-axis for the particular values on y-axis, that is u, which lies between 0 and 1. Okay, that means q equal to infimum of x, such that fx greater than or equal to u. Okay, if there exists an x with fx is equal to u, then f of q equal to u. So q is the smallest x satisfying the condition fx equal to u. Since fx is a continuous function in the continuous case, normally the continuous content and strictly increasing, and that we assume that condition, then q is the unique x satisfying the condition fx equal to u. And that if you have the density function that is equal to derivative of fx, that is dfx, equal to little fx, small fx, then we can associate quantity here, quantile density function, which is defined by derivative of capital Q, that is little q. From the condition f of q equal to u, we differentiate f of q equal to u with respect to u, we will easily obtain the relationship given here, q is equal to 1 over f of qu. Q is equal to 1 over f of qu. Okay. When you look at the history of or the literature review on this particular concept, it is long history introduced by Belgian sociologist Quetelet in 1846. He has used this concept in statistical analysis in the form of interquartile range. But the systematic study on this particular topic was started by Galton, who ordered the observation using the quantiles. For example, he has used the concept called quartiles, medians, interquartile range. And he also derived the sample behavior or the limiting distribution of the sample quantiles. And the first breakthrough in this concept was introduced by Hastings et al. 1947, who introduced a family of distributions derived by quantile functions. And this distribution family was modified by Tukey in 1945, and which is basically the generalization of the Hastings family, Hastings et al. Family, and various other researchers generalized or modified or introduced various families based on quantile functions. A systematic study on application of quantile functions on exploratory data analysis was given by Parson in 1979, who introduced some sample properties and its applications on reliability theory and time series analysis, etc. And there is a book by Karen Dubowitz, 2000, fitting statistical distributions using quantile functions. At the same time, the Gilchrist 2000, who also wrote a book, Statistical Modeling with Quantile Function, which presents the basic ideas and basic concepts, basic applications on quantile functions. Nair Sankaran Balakrishnan 2013 also presented a book called Quantile Based Reliability Analysis, in which the applications of quantile functions in reliability theory has clearly explained. This is about the history of this. Then coming to the various properties of basic properties of quantile functions, you know that the distribution function is right continuous and increasing, so or non-decreasing. The quantile function has the property that QU is non-decreasing, it is left continuous because you are taking the inverse. Then Q of fx is less than or equal to x for every x belong to minus infinity to plus infinity, for which is 0 less than fx less than 1. The gems of fx are the flat points of QU and vice versa. If U is a uniform random variable, then Q of U, that is, has the PDF fx. This is simple because f of QU equal to U, therefore the Qx equal to QU has the PDF fx. The three important properties are listed below. Then if Q1U and Q2U are two quantile functions, then Q1U plus Q2U is a quantile function. The sum of two quantile functions is always a quantile function, which is not shared in the case of distribution functions. And if Q1 and Q2 are positive quantile function, and that means you are considering only non-negative random variable, then Q1 Q2 is again a quantile function, Similarly, Q1 plus Q2 is again a quantile density function if Q1 and small q1 and small q2 are quantile density functions. Then if fx is a continuous and t is non-decreasing function, then t0 equal to 0, t1 equal to 1, then q of tu is a quantile function with the same support effort. For example, x is has a quantile function, then with an x square, t equal to x square, then q of x square is again a quantile function. That's similarly, t of qu is again a quantile function. And in the case of non-increasing, then the t of q of 1 minus u is a quantile function instead of q of tu. If y equal to ax plus b, that is a linear transformation, then the quantile function corresponding to y will be a into quantile function corresponding to x plus b. And if y equal to 1 by x, then the quantile function of y will be 1 by quantile function of x evaluated at 1 minus u. Qy of u will be 1 by qx of 1 minus u. Why quantile functions are important? Then one thing is quantile function has certain properties which are not shared by distribution functions. Like q1 plus q2 is a quantile function. Then second reason is easy to construct a new distributions. That means if you have two quantile functions, then you can easily construct a family by taking q1 plus q2 or the linear combination of these, that is a1 q1 plus a2 q2, and those things you can use. Then you can have the explicit form of the distribution function of rth order statistics. For example, in the case of first order statistics, you have a simple form. The quantile function for the first order statistics will be obtained from that identity, and nth order statistics can be obtained from this identity. And easy forms for distributional characteristic. That means in traditional approach, the distribution function, the properties of distributional functions or distributional characteristics are usually studied by the moments. Here you have another type of distributional characteristic like medians or measure of skewness based on linear moments, and which can, or interquartile range, which can be used for the study on distribution function. And the important thing which is useful in recent years is how to generate random numbers. So once you have quantile function, you can easily generate random numbers. Sometimes this inference procedure and some of the properties which can be used in the quantile setup, which are more tractable than the distribution function approach. Moments, the first one is usual moments. There are different types of moments in statistical literature. One is the raw moments, the other one is central moments. Here the raw moments, which is actually mu r dash, which everybody knows that expectation of x raised to r, which can be represented in terms of quantile functions. And this is based on the assumption that most of the values are concentrated on center points, these moments, or central moments are usually used for studying such things. But in the there are situations where the distributions are heavy-tailed or highly skewed. All those situations, the usual moments are usually not employed. On alternate one is probability-weighted moments. Then you will give different weights for these moments, and the right tail you have higher weight or lower weight. That depends on the situation. So these moments, probability weighted moments, can be represented in terms of linear functions of order statistics. So which is given here, LR, and this is also referred as linear moments. L moments, linear moments. Linear moments is basically a linear combination of expected value of order statistics. that is given here. For example, if you take r equal to 1 here, that is simply the usual moment, mu, that is the expected value of x. L2 will be the half of mu difference, and similarly L3, L4, these can be used to construct measures of skewness and kurtosis. These are given here, L3 and L4. We will consider these moments when you discuss a particular type of quantile functions later. Now, coming to some important quantile functions, as mentioned earlier, one of the breakthrough was given by Hastings, who introduced the quantile function models for statistical analysis, and which was refined by Tukey in 1962, and which is a basic model in terms of quantile function that is given by QU, that is u raised to lambda minus 1 minus u raised to lambda divided by lambda. Excuse me, there is a small mistake, 1 minus u raised to minus lambda, not 1 minus u raised to lambda, 1 minus u raised to minus lambda. So this is nothing but, this is basically a linear combination of two quantile functions. The first quantile function is the quantile function corresponding to power distribution. The second one is quantile function corresponding to Pareto distribution. So if you take this in linear combination of these two, you will get a quantile function. That is what basically the Tukey introduced. Okay. There are other models which can be easily generalized by this. Then another important model on quantile functions was given by Ramsar and Shimisa, who basically again considered a model, that is a very general model, lambda 1 plus u raised to lambda 3 plus minus 1 minus u raised to lambda 4 divided by lambda 2. Here also there is a modification of this, but you can consider different ranges for lambda 3 and lambda 4. Here, the previous case, we have only lambda. Here, various other parameters, lambda 2, lambda 3, lambda 4, all these things. So you can have basically 4 parameter quantile function, and for different values of lambda 2, lambda 3, lambda 4, you will have different ranges. Okay. Here also basic idea is the linear combination of two quantile function and a scale parameter plus a location parameter lambda 1. That's all. Then another one is again the generalized Tukey lambda, which was published in Communication Statistics Theory and Method 1982, and some modification of this is also given here. Okay. Then a 5-parameter family, which is again a linear combination of these power and Pareto distribution. These are also given here. And this is another one which was introduced by Hangen and Lee 2006. Basically, this is again the introduced by the property of the quantile function, that is product of two non-negative quantile functions is again a non-negative quantile function. For example, u raised to lambda 1 is a quantile function corresponding to power distribution. 1 minus u raised to minus lambda 2 is a quantile function corresponding to Pareto distribution. Take the product, so you will have a quantile function. So earlier cases they have considered linear combination. Here he has considered the product of two quantile functions. And we have studied the important reliability properties of this quantile function, and we have used this in different occasions for the data analysis. This is another one. Then Baroda distribution. This is again linear combination of two quantile functions with different parameters. One is u raised to beta, another one is u raised to beta plus 1. And multiplied by a scale parameter. This was introduced in 1977 to study the failure type of the Fisher rate. And he has considered about 50 refrigerator and studied this contact function, and he has applied this contact function for fitting the data corresponding to the failure times, and he could derive the estimate of the parameters and all those things. Then the question is, we have introduced certain contact functions, and we will consider more contact functions later. Then the question is how to estimate the parameters of the contact function. What are the parametric estimates or estimation techniques in the contact setup? Traditionally, in the distribution function approach, there are different methods for the parameter estimation. Usual method is method of moments, equating sample and population moments. Another one is method of maximal likelihood. Then method of least square techniques, and there are other methods also. Even base method and other methods are there in parametric setup. Okay. Now, in contact setup, some of these methods can be transformed, but when you study the properties, there are some special methods are recommended. One method is the method of L moments. That means calculate the sample L moments and equate it to the population L moments. Here we have a random sample x1, x2, xn from a contact function QU. Calculate sample L moments. Suppose we have 3 parameters, then you calculate sample L moments L1, L2, L3. Then corresponding to this, you equate the sample L moments to corresponding population L moments, small LR to capital LR, and solve these equations and find them. One important thing is that this was studied by Hosking in 1990s in a couple of papers, and he has proved that these moments have some asymptotic properties. Some like a maximal likelihood moments, this has asymptotic properties like a consistency, and under certain condition, this has asymptotic normal distribution. The estimates has asymptotic normal distributions. It's a data. Then another one is method of conditional least square. That is there. You take the order statistics and corresponding moments and find the sum of the squares of these two quantities and find the value of parameters which minimizes this conditional least square. Then method of maximal likelihood can be also implemented. Then basically the idea when we have a continuous random variable with the density functions f(x), what we do is we construct a likelihood function, and the quantity which maximizes the likelihood function or the parameter value which maximizes the likelihood function as the maximal likelihood estimator corresponding to that parameter. Suppose in that case what we do is we usually use the construction of the likelihood function and find find the maximum value of theta. For that, what we do is we use the calculus method. Differentiate and first derivative, take first derivative, equate to 0, and find the value and see that this second derivative substituting at that value is less than 0. That is what we do in a simple case. Here what we have is you can write the likelihood function in terms of quantile density function, because we have a relationship f of qu equal to u. From that relationship you can have the relationship between the density function and quantile density function. Okay, using that you can write the likelihood function in that way. But the problem here is this u1, u2, etc., which are nothing but they are the values corresponding to x1, x2, etc., etc. Okay. Then what happens is that u1, u2, etc., un, they always depend on the parameter theta. Therefore, you cannot differentiate this likelihood function with respect to u, with respect to theta and find the value of theta. Because the earlier case, you can use directly, because x and theta you can differentiate with respect to theta and in the under certain regularity conditions, and you can calculate the value. When the support of x does not depend on theta, you can calculate the value. Sometimes you have to use some numerical method to finally compute the maximal likelihood estimator. But here these UAs are depending on theta. Therefore, you cannot directly differentiate with L theta. And so what we have to do, you use the concept called this total derivative and other things. Or another way is you have to use some algorithm for finding the maximal likelihood estimator. So this Gilchrist 2000 book, he has provided one algorithm for finding the maximal likelihood estimator. This is one. Then there are other methods which are not discussed here. Now my objective here is next 25 minutes, what we are going to do is application of this quantile function. I'm concentrating on reliability analysis, and finally I give specify some applications on other areas. Reliability theory or survival analysis, one of the basic concepts is hazard function, which is also referred as force of mortality in demography, or age-specific failure rate in epidemiology, Mills ratio in economics, etc. Suppose you have a random variability which is a non-negative in the case of lifetime studies, and you can define hazard rate at point t is the instantaneous rate of failure at time t, given that it has survived up to time t, given in equation 1. And if the x is a continuous random variable and the distribution function ft is differentiable with the density function of small ft, you can have this relationship ht is equal to small ft divided by the survival function capital St. And the hazard function and survival function can be easily related. That is given by 3 and 4. Then there are various shapes for the hazard function. This is the utility of hazard function. When you study reliability theory, one important question is what is the role of hazard function in reliability analysis? If you consider the survival function, it has a unique property that is always non-increasing property. But so we cannot compare two survival functions easily, or you cannot study the properties of survival function in detail or the failure pattern in detail using survival functions. But when you consider the hazard function, it has different shapes or behavior, that is increasing hazard rate, decreasing hazard rate, bathtub hazard rate, and upside bathtub hazard rate, and there are other types of hazard functions, etc. So these are some of the shapes which I just present here. So for example, if you consider the exponential distribution, we know that the hazard function, that is a constant. So this is a constant one. No. And if you consider the Newton distribution, and it has two properties, that is increasing hazard rate based on the shape value which has a greater than 1, and which has a decreasing property when the shape parameter value which lies between 0 and 1. So that is that. Then another important concept in the reliability theory is mean residual life function, or first residual life. Residual life is defined the x minus t given x greater than a. When x represents the random variable lifetime, x minus t given x greater than t, that is the residual function, and the survival function of st, this random variable is defined by this. Then expected value of this x of t, that is referred as mean residual life function, which is very well known, which can be expressed in terms of survival function. And another concept is variance residual life, which is also another important quantity which can be used for study the spread of the residual life, which is also given by this variance residual life. Okay, it's also given here. Basically, the variance of x minus x or x minus t given x greater than x. Then during 1990s, there are other concepts which are useful reliability were derived, like revised hazard rate, revised mean residual life, revised variance residual life. When we discuss reliability data analysis or survival data analysis, there are different types of data. For example, some situation you have a right sensor data. In certain situations, you have a left sensor data. So, for the right sensor data, traditional concepts of failure rate, mean residual life, they are useful for the analysis and modeling. But for the left sensor data, those concepts are not very useful because of the data nature. These cases, what we do is we consider the reverse hazard rate, that is defined by x, which is nothing but the distribution, the density function divided by distribution function, which is defined as limit x tends to 0, probability of t minus x minus delta x less than capital X less than x given x less than x divided by delta x. Okay, so what do we have here? Here, probability of t less than equal to t less than t plus delta t. Instead of that, we start at t minus delta t less than equal to t less than t, given that t instead of t greater than equal to t, we have t less than equal to t. That is left sensor type of data. This is useful. Revised result. Then revised mean residual life, which is the expectation of that quantity t minus x given x less than t, and revised variance residual life. These concepts were already derived in the early literature, and there are relationship between the revised hazard rate and usual hazard rate, and also these concepts are also mutually related. Then coming to these are the traditional concepts using distribution function. Our objective is the role of quantile functions in reliability theory. So then how to transform these concepts into quantile functions? Then we define the hazard quantile function. The hazard quantile function is nothing but capital H of u. This is H substitute as x equal to q. This is when you substitute this quantity f of u here. F of t divided by s of t. If you substitute f of capital Qu divided by s of Qu, we know that f of capital Qu is 1 by little Qu, and s of Qu is nothing but 1 minus f of Qu, that is 1 minus u. Therefore, we have this expression. So, h of Q is interpreted as the conditional probability of failure of a unit in the next small interval of time, given the survival of unit at 100 into 1 minus u% of distribution. And like in the traditional distribution function approach, we have a relationship between quantile density quantile function and hazard quantile function, which is given here. If you know H, capital H, you can find Q, or if you know Q, you can find capital H. Is the some of the important quantile functions and corresponding hazard quantile functions. We will W capital, so beta Govindaraju. The Weeble, Pareto, rescaled beta are the exponential. These cases, you know that you have simple forms for distribution function and easy forms for hazard rate. But here, last two cases, you do not have simple forms for distribution function, but we have simple forms for quantile function. Corresponding hazard quantile functions are given in the table. Then shape of hazard quantile function. One important property here is the property of monotonic property of hazard quantile functions. Hazard rate is preserved when you transform into the quantile setup. That means if HT is increasing, then the corresponding H of Qu will be also increasing. So this is due to the property that QU is always non-decreasing function. Okay, that is that. Then one can also transform the mean residual life function into the quantile setup, which is defined as mean residual quantile function M of u, which is given by this quantity. So M of u is defined as mean remaining life beyond the point 100 into 1 minus u percent of the distribution. We can again relate M of u with QU, and we can also relate M of u with H of u also. Some of the distributions with the quantile functions and corresponding M of u. Then the variance residual quantile function, which can be also introduced by transforming the variance residual life function, which has a simple form given in 7. Reversal Lazar quantile function, which has a AU, and reversal mean residual level, reversal variance residual level. Then we introduce a new quantile function that is represented by the Hazard quantile function, which has a linear form, HU equal to A plus PU. Then corresponding QU equal to, if you substitute the earlier identity, that is the identity connecting HU and QU, we have QU is that form. Please note that the distribution function corresponding to this HU or QU do not have explicit form. Okay, so this is a quantile function which can be only expressed in terms of quantile function or the linear Hazard quantile function. Okay. And then if you consider these quantile function with the then we can derive the distributional characteristic as discussed earlier. That is the first 4 L moments. You can have lambda 1, which is nothing but that is the mean of this quantile function will be this, and you can have the lambda 2, lambda 3, lambda 4, 4 linear moments, which has simple forms here. And the L coefficient of variation is defined as lambda 2 by mu. We usually you have coefficient of variation in traditional setup, that is a ratio of second and first moments. Here there is lambda 2 divided by lambda 1. That is the total. Yes, sir. Then we have to measure the skewness of distribution, L skewness of L coefficient of skewness, which is given by lambda 3 by lambda 2. L coefficient of kurtosis is lambda 4 by lambda 2. These measures can be used to understand the shape of the quantile function. If you put the theta equal to B by A, then you can easily represent those things in terms of theta, that is given by lambda 2, lambda 3, lambda 4. These are here. Then what is the advantage? The one advantage here is, if you represent theta, then theta, the range of the parameter space can be easily specified. That is, theta lies between minus infinity and infinity, minus 1 and infinity, and then the range of various measures, that is, if theta lies between these two values, corresponding lambda to tau 2 values and tau 3, tau 4 values can be easily obtained. This is the advantage for converting or transforming these parameter values. So the parameter theta also plays an important role in distinguishing the members of the family. That is, when theta has a particular value 0, you will have exponential distribution. Theta equal to 1, we will have a half logistic distribution. Theta equal to lies between minus 1 and 0, we have exponential geometric distribution. And theta lies between 0 and 1, and or theta greater than 1. Two cases we have different types of Marshall working type models. There are some characterization corresponding to the linear quantile function. I am not discussing too much. That is based on linear functions of these things, Hazard function or MU and reversal Hazard function, etc. Then Then this can be used to fit a data. One important data set which we have considered is failure times of electronic components in an accelerated lifetimes. This is a small sample data without any censoring, and you can easily obtain the parameters, and based on the method of L moments, and estimates of A and B are given. These are the given, and corresponding HU is also given, which is a linear function, and QQ plot, and this to find the adequacy of the data, model, we use the QQ plot, which is also a reasonably a good fit here. This is an application of that model. Then another concept which is useful to study the non-monotonic behavior of the hazard function. For example, bathtub models or upside bathtub models, which is referred as score functions, Parsons score function, defined as Glazer's function, which is nothing but minus f dash x divided by fx. Minus f dash x, that is the density function, derivative of the density function divided by fx, which is usually referred by eta x. This was introduced by Glaser in 1980 paper and was studied by Deshpande et al. In various papers to understand the behavior, non-monotonic behavior of hazard function. One can consider a similar concept here, that is Parsons score function, which can be also used to study non-monotonic behavior of hazard quantity function. This is defined by Ju, that is Q dash U divided by QU square. Then Ju and Hu are can be the relationship between Ju and Hu can be used to construct new models. For example, if you have the Ju in this particular format, you will get little Qu in this way. This is a new model which was introduced by Nair and myself in a paper appeared in statistics. And Qu is u raised to k into u raised to alpha multiplied by 1 minus u raised to minus of a plus alpha. Then this distribution has different behavior for the hazard quantity function. For example, for a particular value of alpha and a, you will have an IFR model, and you have a DFR model, you have an upside bathtub model, we will have a bathtub model, and some special values for alpha and a, we will get different distributions like logistic, Muralidharan, exponential, rescaled beta, etc. So this is a very general family, and it has applications in reliability theory in various occasions depending on the behavior of hazard rate or hazard quantity function. And we have used one data set which used in Klein's book, that is data consists of survival times of 90 patients, cancer patients, and we have used this model, particular model, quantity function model for fitting the data set, and the estimates of the parameters are computed using a method of percentage. This is another method of percentage, and this is values, alpha value, a value, and k value, and the behavior of data HU. Behavior of HU, you can see that it is an upside bathtub model. I think you have a session on reliability theory after this, and you will have more on bathtub and upside bathtub in that session. There are other families, that is QU in this particular form, other families of quantity function which can be used in different occasions based on the data behavior in terms of hazard rate. This is also a very general family. Then this is another family which is completely different from earlier one. Here you can see that this is 1 minus u raised to minus a into minus log 1 minus u raised to minus a. This is nothing but this quantity function. If you look at this quantity function, you can and you can finally see that this is the product of two quantile function. The first quantile function is 1 minus u raised to minus a is the quantile function corresponding to Pareto distribution. Next one is the quantile function corresponding to Weibull distribution. So this is a product of two quantile functions, and you can say corresponding to product of two quantile density functions. So you can see that. Then there are other ones. Wiki by distribution, there are other things. I'm skipping this. Then when we find the non-parametric estimate for Hassard quantile function, what we do is here we use the kernel density method for the estimation. Suppose you have a random variable x, which is lifetime random variable, censored by another random variable y, and in practice we observe either x or censored random variable z, we observe a y that is equal to minimum of x or z, that is, and censoring indicator delta. Then the random variable x has the distribution function f, y has the distribution function h, and z has the distribution function g. Assume that x and z are independent, and then the survival function corresponding to y can be represented in terms of survival function corresponding to x and z using the property of y equal to minimum of x and z, that is given here. Then you can have the Kaplan-Meier estimator, which is well known in survival analysis, which can be calculated using the data set. And then you have a kernel function, which is defined here. Due to time constraint, I am not going to explain all these things, properties of kernel function and other thing. And finally, we can derive a non-parametric estimate of HU, which is given here. Here, this K is nothing but it is a kernel value, and Fn is the non-parametric estimator of the that is the Kaplan-Meier estimator of the distribution function, and Qn is the corresponding sample quantile function, and little qn is the corresponding sample quantile density function, and Hn is the bandwidth. These quantities can be easily calculated when you have a particular value of k. Then the question here is, when you use kernel density function, there are two questions. What will be the appropriate kernel? What will be the appropriate or optimal bandwidth? Then kernel which we usually use is a symmetric one. Usually one can use Gaussian kernel or triangular kernel in for the estimation of the particular quantity. But the bandwidth what we use is the one which has minimum MSE. We try with the different values of H and find the one which has minimum MSE. Then again another data set which has used appeared in communication in statistical theory and methods, and this data set was used here. I'm not going to discuss. Then there are other interdisciplinary concepts using quantile function. One is Lorentz curve. This is basically used to study the income gap of the population, and they are defined by in terms of quantile function, and this is given here. And Lorentz curve has introduced early in the 80s, but we can have a simple expression in terms of quantile function which is given in this particular paper. Then Born-Ferroni curve, which can be also used to study the income population. Basically, the ratio of the mean of the poor, mean income of poor to the total income of poor, that is given by this Born-Ferroni curve. Then total time of test transform, which is used in reliability theory, that is can be also expressed in terms of the. Then ROC curve, which can be used to study the sensitivity and specificity of the data, which can also represent in terms of quantile function. Then lenticular curve. This is useful in informatics. That is how this index can be measured and which can be used to measure the particular words or particular letter appeared in different pages that is key. Then value at risk, that is nothing but this is a quantity which is used in finance. This is basically a quantile function or percentage value. Then the entropy, there are various definitions for entropy. The first one, the basic one is Shannon's entropy, then Renes's entropy, and Thirl's entropy, and there are different versions of entropy. These entropies can be transformed in terms of quantile function, and we have introduced the first paper in statistics and probability lattice, where the quantile based Shannon's entropy and its residual values, and there are various extensions of this work in different papers. Then expected shortfall, which is also useful in finance, which can also introduce in terms of or represented in terms of quantile functions. These are things. Some of the important references which was pointed out here are this. So the recent book, Sankaran and Balakrishnan Quantile Based Reliability Analysis. Okay. Thank you. Any questions?
Okay, thank you, Dr. Sankaran. Any questions from audience side? I think there is no questions on this chat box. So, anybody who wish to ask any questions or queries?
Those who are not familiar with quantile functions, please refer two books. One is Gilchrist 2000 and Nair 2000. Excuse me?
Okay. Okay, any questions? I think you heard about one reference text also. You can note down and it will be very useful for you.
Dr. Jensen, any specific questions I can answer now, or if you are not very familiar, you can refer these two textbooks.
Okay. So, is there any specific question from US side? Otherwise, you write these questions directly to Dr. Sankaran by mail or WhatsApp, or you can make use of anything. So, on behalf of all present in online as well as offline, I express my heartfelt thanks to Dr. Sankaran. Thank you very much, Sankaran.
Thank you very much.
Okay, thank you. So we can pass on to the next talk. Is it okay? I think Dr. S.M. Sunoj is there. I think Dr. S.M. Sunoj.
Sir, I think there is a technical issue. Sunoj sir will be here in few seconds.
Okay, so we can wait. So you. So we can take 5 minutes break. I think that's better. Okay. Good morning, Dr. Sunoj. Can we start now? Okay, network. Let us start now. എനിക്ക് കേൾക്കുന്നുണ്ട്. തുടങ്ങിക്കൂടെ നമുക്ക്?
ഞാനിത്
Okay, Gautami, can we start now?
Yes, sir. We can start now.
Okay. Next talk we have. Next talk is on reliability, basic concepts and properties by Dr. S.M. Sunoj, Professor, Department of Statistics, Cochin University of Science and Technology, CUSAT, Kochi. I can proudly say that he was our alumnus, that is alumnus of St.Thomas College, and who secured first rank in MSc Statistics of Calicut University and third rank in BSc Statistics of Calicut University. And beyond that, during the course of MSc, he secured NET and JRF, that is UGC JRF. From that examination, UGC CSIR combined examination. Okay, Dr. S.M. Sunoj he has teaching experience of more than 20 years, and he acquired doctorate from CUSAT itself, and his area of interest are distribution theory, reliability modeling, information measures. He has more than 55 papers in national and international journals, and has published, edited, collected papers of Professor N. Unnikrishnan Nair. He guided 5 students to their PhD, and he started his career as lecturer in Government Sanskrit College in Pattabhi in 1998, and joined in CUSAT in 2001. We know we are dealing with basic concepts of reliability. So just I mentioned the difference between quality and reliability as an introduction. That is, quality shows how well an object perform its proper function, while reliability shows how well this object maintains its original level of quality over time through various conditions. If we are representing that time as capital T, then reliability function RT, as we all of us know, that is probability of T greater than T, which is 1 minus Ft, which is 1 minus the so-called distribution function. It's we can start from there onwards. I know that Dr. S.M. Sunoj will start from the basic concepts of reliability. Okay, welcome, Dr. S.M. Sunoj. Please carry on.
He's always happy to rejoin my parent college. So I think almost every year I'm or offering some talk in the college at different topics. So today there are some disturbance coming in. I think Jensen sir, can you mute? Okay, that's good. Actually, there are different topics normally we speak. When I talk to the head of the department and the coordinator, so they actually suggested that most of the audiences, majority of the audiences are the students undergoing this graduate and postgraduate level. So there is no point in introducing purely the research level talk. So it will be very difficult to follow most of the students. So when I introduce some recent works of us, so it is better to introduce some new, not new, some fundamental topics. As mentioned, this reliability is one of the hot topics, and knowingly or unknowingly, we are all using this concept in our daily life. But the question of how we can quantify it and what are the different areas in reliability. So, of course, there are plenty of sub areas in reliability theory. So you can see that there are some engineering reliability based design, then reliability modeling, which include this statistical reliability, and there are different other topics related to the reliability. So there are many journals publishing articles purely in this area, reliability, especially the some of the journals you might have heard of it, like IEEE Journal of IEEE Transactions on Reliability, then Naval Research in Logistics, and there are of course plenty of other journals that are publishing articles related to the reliability. And fortunately, I'm also I could publish some of works in this area. So here we begin with, as mentioned by Jensen sir, I try to introduce the basic concepts and how these topics are used in different sub areas, and some of the related areas which are also very popular nowadays. So back to let me just
Sir, are you
present
sharing
my,
the screen?
yeah, I'm going to share.
Okay,
I'm
okay,
going to
okay.
share. Okay, so right now I haven't shared. Okay, so let me go to the slide now. Can you see the my slides? Can you
Yes,
see the slides?
yes, sir.
Okay.
Yes, sir, we can see.
Okay. So the title I suggested or I propose here is the reliability, basic concepts and properties. So this is part of this national webinar on recent developments in statistics and probability, organized by the Department of Statistics, St. Thomas College, Thrissur. Now, okay. Yeah, okay. sorry, there is some problem in the Acrobat Reader. Can you see the slides now?
Yes, sir. We can see.
Okay. I think there is a problem in that Acrobat Reader. It is updating. Okay, it will take some time. So let me go with this. Okay. So this is the outline of my talk. Reliability, basic concepts. Here we introduce some of the basic concepts and measures related to the reliability function. Then aging and associated criteria, log concave and convex distributions, and some of the important stochastic orders useful in reliability analysis. So moving to the introduction, generally we consider a device to be reliable if it works at the expected level whenever called upon to do so. The notion of reliability is often taken as this definition, I think Jensen sir has already mentioned. It is a probability that a device or system that will perform its intended function under conditions specified for its operation for a given period of time. Thus, reliability can be viewed as a measure of successful performance of a device or system. So when it does not satisfactorily perform, we say that the device has failed. With a wide range of products ranging from equipments for daily use to sophisticated machineries, the period of their successful operation is a matter of considerable interest to all. Reliability analysis has made rapid strides in the last few decades to become a major discipline. So those since many of the PG programs, this reliability is a part of their course. So many of you have already come across the different topics related to the reliability or different topics in reliability. So this is for them. This is just a recap, and some of the things will be new only. Reliability theory is a body of concepts, methodologies, and practices that led to the failure-free operation of products and systems. The importance of reliability of components and systems is also recognized at every stage of daily life, ranging from consumer products such as TV sets, mechanical equipments, structural systems, and automobiles, to large systems such as trains and airlines. So in daily life, we come across different type of equipments or products. In all these cases, we may be interested in knowing the reliability of that particular item or product. So, and how it is measured, and because depending on the nature of this type of items, the quantification or the evaluation or computation of the reliability change. Okay, so that we will discuss later. In fact, in the beginning, in the last slide, I have proposed a definition for reliability. Reliability is a probability that it is a successful operation of time, or probability that a device or system will perform its intended function under conditions specified for operation for a given period of time. Okay, so with this definition, we normally see that it is always depends on the on a time scale. Those who have studied reliability, or the definition which proposed by Jensen's are, he said reliability is probability of x greater than t, probability of survival of this random variable beyond a time t. Okay, and it is in fact a complement of the distribution function. But in certain cases, we cannot apply this definition as it, that I will explain through an example. Now, our primary concern in this in the present discussion is on reliability modeling that deals with it is not only restrict to the reliability modeling alone, but I also include I have also included certain other topics like the reliability based design in the presentation. But mainly the topic is, or the talk is focused on this reliability modeling part that deals with the identification of the mechanism that generates the failure times of devices. So when you have a failure data, then based on the failure data, what all inferences one can propose. So that is the discussion mainly concentrate. So we can make use of different measures. Some of them are very popular, and some of them are, even if they are not that much popular, but they are all useful in certain situations. So in that context, these the next few slides will be quite useful for those who are studying the reliability and reliability modeling. So now, in reliability, one important quantity, or the random quantity, we usually take it as a lifetime. Okay, so what is lifetime? By lifetime, we mean the interval of time during which a device functions before it fails ultimately, and a mathematical model for the lifetime that we seek. So we always try to identify some of the distribution. If you are able to identify the underlying distribution of this random variable lifetime, then the things will be more easy, because we can make use of the properties of these distributions for the inference, or for many prediction purposes. Okay, or to identify some other features of, or other characteristics of the given population. Okay, so throughout our discussion, we treat lifetime as a continuous random variable. I haven't looked into the discrete part, even if we can study in parallel the discrete random variable and how reliability is measured in that context. Okay, so but in the present context, we restrict our discussion on the continuous type of random variable. Though we talk about random lifetimes and their distributions, the deliberations here will be equally valid for the general class of duration variables, where the interest is the time taken for the occurrence of a specific event. So, okay, thus the concepts and methodologies in reliability theory with a different nomenclature or interpretation consist with the context have found applications in actuarial science, economics, medical science, epidemiology, demography, etc. Now you can add more areas to this, and in any topic, this will be more useful, especially in medical science. This topic has another name, and which is the survival function. Instead of the reliability function, they call it as a survival function, and the associated measures are all very useful in estimating the probability of survival of an individual with regard to some disease occur. Okay, so that in the survival the area we call it as a survival analysis, and in survival or in the study in clinical trials. In all these cases, we will be more concentrating on the inference part of the reliability function. Okay, so that part is not going to discuss here. We, as mentioned, or as I have already mentioned, this talk will be more concentrating on the other part, that is the reliability modeling. Okay, now here comes the quantification. So the question of how you quantify it, because it's a probability. So this is the definition, proper definition for reliability function. Let X be a non-negative continuous random variable defined on a probability space omega script AP with a distribution function capital F. Sorry, this definition is this is probability. This is a typo. Probability X less than or equal to X. You all know this is a cumulative distribution function. The random variable X could represent the length of life of a device measured in units of time. The function f bar x, sometimes we use r of x, capital R of x. Here I am using f bar itself because it's basically the complement of the distribution function. So f bar x, we know that it is 1 minus the complement of the probability of x less than or equal to x. So reliability function is nothing but the probability that x greater than x, where x is, since x being a lifetime, it is always non-negative. But in certain occasion, it is not necessarily restricted to the non-negative setup. Non-negative restriction can be removed, and you can extend to the whole real line. So there are, of course, different examples where one can include, where we can make use of the distributions that ranges from minus infinity to plus infinity. For example, the normal distribution. So based on the normal distribution, you can evaluate the reliability. But being a lifetime random variable, we generally take x greater than or equal to 0. So that is why f bar x is probability of x greater than x, x greater than or equal to 0. It is non-negative. Okay, this is called the reliability function or survival function. Now, one important measure closely associated with the reliability function is the hazard rate. Hazard rate is also very familiar to most of you. Here, this is it is also called instantaneous rate of failure, and it is called the failure rate in reliability, whereas it is called the mortality rate in actuarial studies, or demography, it is called the force of mortality. So how we define it is simply f of x divided by f bar x, and f of x, small f of x is a probability density function. And so the next definition is, this is the actual definition because it is a limiting probability, and the first equation number 1 can be utilized only when the density function exists, the probability density function exists. But you know, there are certain models where the probability density function do not exist. So in such cases, we cannot use equation 1, but equation the next level, that is a limiting probability. So h of x is limit delta tends to 0, probability that x less than capital X less than or equal to x plus delta. So we find the instantaneous probability within an interval x to x plus delta, subject to the condition that x has, the random variable has already survived x units of time. Okay, so delta hx is approximately the conditional probability that a device which has survived x will fail in the next small interval of time, delta. So this is a quite meaningful definition than equation number 1. So this is the complete definition. Now, from that expression, once the density function existed, or using this equation 1, you can have the equation 2. Equation 2 is nothing but an identity that uniquely or that provides a unique determination of the underlying probability density function or cumulative distribution function. That is, if you know the form of or the functional form of h of x or h of x, the failure rate, then you can identify the underlying distribution through this relationship. Okay, so just plug in this functional form in that in this integral and evaluate in this integral, you'll get the underlying distribution. Okay, this is a characterization result. So that's hazard rate determines the life distribution uniquely, so that both provide equivalent information about x. Now, from physical consideration or from an empirical plot of h of x, one can approximately find the functional form of h of x. If you have the failure rate is available, and if you plot the failure rate, you will get a rough idea about the nature of this the failure rate, and based on that, it is possible to identify the underlying distribution. So the identification of the underlying distribution is very important, because once we are able to identify a underlying probability density function or a cumulative distribution function, the advantage is we can make use of all the properties of that distribution. It is not necessary to look into the other things, because once it is belong to one distribution, or if you are able to identify one exact distribution, then all the properties will be applicable to that particular data set, and we can use those properties for inference. Okay, so when these are the conditions of the h of x. H of x is always non-negative, and integral 0 to x h t dt is finite for some x, and integral 0 to infinite h of x dx is infinite. So these are the conditions, and a function related to the hazard rate is a cumulated version. What is this cumulated version? So sometimes we will be more interested in finding the cumulative hazard rate, because as time goes on, what will be the nature of this hazard? So that will be interesting. And in that case, instead of using the hazard, we will be more interested in finding the cumulative hazard, and that is denoted by the capital lambda x. It is cumulative, that is integral 0 to x h t dt, and since x is non-negative, this lambda 0 minus 0, and lambda x is increasing, and lambda x is infinite x as x infinite, x tends to infinite. So this is a very simple example. The use of this function, the failure time of mechanical component follows Weibull distribution. Suppose you know from the experience or from the given data set, if you have already identified that the underlying distribution is Weibull, then the failure time of this particular mechanical equipment, we assume that it is following Weibull distribution, with f bar x is exponent of minus of this x minus L divided by eta minus L whole raised to beta. So this is a three parameter Weibull distribution. It contains the location, scale, and shape parameters, such that and the beta is also estimated. Maybe using the maximum likelihood estimation method, we have estimated the parameters, or using any method of estimation, you can estimate the parameters involved in this particular model, and it is found to be beta equal to 3, eta equal to 2500, and L equal to the location parameter is 1000. Now, what will be the reliability of the component and failure rate for an operating time of 200 hours? So here we are interested in finding what will be the survival, the nature of the survival, or in other words, if you are interested in finding the reliability of this particular mechanical equipment when it has already survived 200 hours. So what will be its reliability? So by just plug in these values in this expression, it is 0.7436. So for this particular mechanical equipment, now we can conclude that there is a 74.36% chance that this particular mechanical component will survive beyond 2000 hours, because this is very important in engineering system, because once we manufacture or we include or attach a new component, etc., the engineers will be more interested in how far or how long this will work, and what will be the survival rate, or what will be the reliability of such a component or such systems. Sometimes system is nothing but a combination of components. Here in this example, I have taken only a component, a mechanical component. So one can conclude here that this, as far as this mechanical component is concerned, this reliability function is reliability is 0.7436, which means 74.36% of surviving this component beyond this 2000 hours, whereas the failure rate is very negligible. That is why it is obtained as 0.00089 failures per hour. So in that sense, but if you know the underlying distribution, the evaluation of the, you can easily find it that the usefulness of identifying an underlying distribution, and how easily we calculate the reliability and failure rate through these expressions. Okay. Now, the estimation of reliability and hazard function from empirical data. Suppose this is just to fill the gap. Suppose you have the number of components and how many components survived at a time t. If you observe the number of items survived at a time t, and how many items failed at a time t. Okay, so based on that, is it possible to find the reliability as well as the hazard rate? So consider a fixed number of identical components tested simultaneously under similar operating conditions, n equal to number of identical components tested. So suppose we allow n items to operate. Okay, so in the beginning, suppose you have 1000 items, and we allow these items to operate, or we allow these items to function. Okay, so at each interval you look into, or at each time point, we count the number of components survived or number of items failed. So you can easily count the number of items at each of these time points. Okay, t. So that is denoted by NST and NFT. Then in that case, the reliability is nothing but being a probability, it is NST divided by capital N. So it ranges from again 0 to 1. Whereas HT is a rate, and HT is NST minus NST plus delta T. So from one time point to another time point, and we can find the rate of failure, and this rate can be using this formula. Okay, now these are some of the important probability distribution and its survival function, as well as the hazard rate. You can see that exponential distribution is here, Weibull distribution, Pareto 2, recycled beta, power distribution is here, Burr distribution is here, generalized Pareto, inverse Weibull, generalized exponential, log logistic, exponential, geometric. So there are many distributions, and more distributions are here. This is some of these distributions may not be familiar to you, but it is interesting to know these are some of the distributions used in reliability theory. Greenwich distribution, log Weibull distribution, modified Weibull distribution, generalized Weibull distribution, Gompertz distribution, quadratic hazard distribution, Hedgehoth distribution, generalized power distribution, logistic exponential distribution. So in all these cases, you can see that as far as the failure rate is concerned, the failure rate, both the failure rate and the distribution function possess closed forms. Okay, so there are certain occasions, the distribution function do not possess a closed form expression. You might have noted the utility of the quantile-based analysis and quantile function in such cases where there are many cases where the quantile function exists, but no closed form distribution function. Okay, so even if there is no closed form distribution function, the quantile function can be utilized. So in that sense, the quantile analysis or quantile function is a alternative method, and I think Sankaran sir has explained exhaustively explained those topics. So let us move to the pattern of failures. So when you look into the failure rate, then we'll be more interested in the nature of this failure. Okay, so with regard to the electronic and mechanical type of equipments, you can see that this is very important because by looking into this pattern of failure, you can sometimes identify the nature of the distribution. Okay, so most electronic and mechanical components and systems deteriorated during use as a result of elevated temperatures, chemical changes, mechanical wear, fatigue, and a number of other reasons. There are plenty of reasons that lead to the failure of an item. Okay, reliability of the system, the time at which failure occurs will be primarily random variable. Many structural systems, so there are some basic difference between the electronic and electrical equipments and mechanical and structural system. So many structural systems tend to deteriorate with time, except by mechanisms of fatigue and corrosion. In some cases, the structure may even get stronger with the time. Okay, for example, strength of concrete increase with the time. Now this is a familiar curve, which is known as the bar-top curve, and this is actually depicts the failure pattern of a random variable x, and that is why you can see here the bar-top curve is a curve with the x-axis denote the time and y-axis denote the failure rate. And from this curve, this is the general pattern applied to most of the electronic and electrical equipments, and also it is applicable to the human being and human life, and in demography also this is taken to be a standard model to the lifetime of human beings. So there we expect a steep decline in the failure rate in the beginning, which we call it as a infant mortality period, because in the beginning the failure rate will be very high. At birth there is a higher chance of mortality, and gradually it steeply decreases to a point, and that period is known as the infant mortality period, and after that we enter into a useful life period. So there is in that period we expect a constant failure rate, but a random number of failures we may expect. That is why it is not reaching to zero, the x-axis, and then after sometimes because of the aging, the rate of failure or the mortality will increase, and that period is generally termed as the wear-out period. Now moving to the system reliability, I just want to mention some of the general systems, system reliability concepts here. The following are different types of commonly encountered engineering systems. One is a series system. I haven't actually included the figures of the series system, but you will I think you can easily understand what is meant by the series system. Series system is that fails whenever any one of its components fails. Okay, if if the components are connected in a series manner, which means that if any one of the component fails, if the system fails, then that type of system is called a series system. Okay. Now the reliability of this series system is simply the product of the reliability of each of the components when these components are independent, and if they are dependent, we have to make it take into consideration of this dependency. But in most of the cases, we assume that the components are independent. Whereas parallel system means it fails only when all of its components fails. So if one fails, that won't fail the whole system. Okay. So if the components are connected parallelly, that means that the system will fail only when all of its components fail, and its reliability is 1 minus product of 1 minus f bar I, where again the components are independent. The other type of systems we generally encounter is called the k out of n systems. K out of n system means you have n components, but the system will work even if any of the k components in operating condition. Okay, so that is the k out of n system. So the reliability is nothing but the binomial probability, and you can see the expression here as a binomial probability. Then there comes the mixed series parallel or parallel series systems. Sometimes we may have components which are connected, or we have set of components that makes a system, and this. But you cannot apply directly this. You cannot identify it as a series or parallel. But if you are able to identify them as subsystems, and these subsystems are either parallel or series, then it is treated as mixed series parallel or parallel series systems. Another type of system is the complex system. This is a more complicated one. From the name itself, is a complex system. So there is no identification of this series parallel or mixed series parallel pattern. That is not possible. So, but they are connected quite random nature. But if you want to find the reliability of the whole system, then how it is possible? So there are generally three methods used. One is called the enumeration method. Second one is called the conditional probability method, and the third one is cut set method. So among the three, the third one is more popular. Enumeration method is very simple. Enumeration method is we identify each of the components attached to the system, and then enumerate each component's status and then calculate the reliability of the system. So that is enumeration method. That is very time consuming method, because as the number of items or the number of components increases, the evaluation of the reliability of that system is much complicated. So the complication increases exponentially as the number of components increases. Whereas the conditional probability method is simple. Here in this case, you identify a critical component from the system. The system contains many components. Among these components, very critical, or that may cause the to fail. So you identify based on the status of that particular component, you can find the reliability of the system. That is called the conditional probability method is applied. That is why it is known as conditional probability method. And the cut set is a more popular and more dynamic method, used by engineering systems. Cut sets and minimal cut sets. So what is cut set? Cut set is nothing but a set of components that when failed will cause the system to fail. So among different components, if and that set is okay, and based on that you can calculate the reliability of the system. Okay, so that is now reliability enhancement is another problem generally used here. The probability of reliability enhancement arises when reliability of an existing system is found to be inadequate. It is possible. Sometimes you need to enhance the so you enhance the so because in cases this contains if you improve or if you enhance the reliability of a component, sometimes it may improve the reliability of the whole system, and that itself based on certain conditions or certain constraints. So that is what we mean by this reliability, the reliability enhancement. So reliability of the system can be enhanced from a current value at bar naught to a new value at bar naught plus d bar naught, by improving the reliability of one or more its components. We can also improve the system reliability by increasing the reliability of most sensitive component, weight, volume, and cost like a component for reference. So, when you change the status of one component, it may result in certain other problems. So that is a constraint too, and that may be its weight, that may be its volume, or that may be some cost constraints. So we need to consider these things while when we try to enhance the reliability of the system. So that is also a problem or an area nowadays people are addressing. Okay. Another problem is a strength-based reliability. So, so when this strength are used and when it is important, okay. So there is a major difference between electronic and electrical systems. So these two systems and electrical systems functions almost similarly because it depends on the time, whereas the mechanical and structural system function differently. Most electronic and electrical components and systems deteriorate during the use as a result of elevated operating temperature or other similar reasons. I have already mentioned about that. A particular component may fail one of these reasons. May fail the okay, so to not have multiple factor. So when load is strength it mainly depends on the load applied and the strength or the yield strength of the item. Okay. So or circumference is safe and reliable, is the standard essence of the systems. So in this case, it is not a complex redundance. Now we can define the two way. One is the strength S and another is the load L. So naturally, when strength L, there's little chance that the item fails. So the probability of that event is defined as the reliability. Okay, so probability of the redundant or this probability of the mass redundant. So this is the expression to evaluate the reliability, and if you have the distribution, because you have two variables, strength S and load L, we can use the probability density functions of these two random variables, and you can evaluate or you can propose or derive expression to evaluate the length. These two are the second and third expressions or identities are generally used to evaluate the reliability of a system, reliability of mechanical and structural system, where you have two random variables, or if you have some information about the two random variables, strength and load. Okay. Now let me. This is the plot of this figure. I mean, two random variable. This is the general plot. You can see that the failure rate, probability density function of the load L, and the failure rate probability density function of the strength S. And you can see this common area or overlapping area that actually determines whether an item will fail or survive, or it will be functional or not. Okay. So let me go through an interesting example, which is generally used in a mechanical component. This is in fact a cross section of a gear tooth. You might have noted the gearbox in a vehicle, and if you look into the cross section of gear tooth, there are many tools attached to one wheel, and the strength or the reliability of this particular hello.
Hello. You have to finish within 5 minutes. Time is up now. Dr. Sunoj.
Okay. So I think okay. Let me go with this example. I shall conclude this example and go into and summarize. Okay. So this is the cross section of a gear tooth. So the question is how we evaluate the reliability of this particular gear tooth. Okay, whether it will survive or not. Okay, so here the question is, I'll propose a question here. The bending stress developed in a gear tooth is given by the Lewis equation, small s equal to Ft into Pd divided by Wy, where Ft is a tangential load acting on the gear tooth, and Pd is the diametral pitch with the P, small p is a circular pitch, and W is a face width, and Y is a Lewis form factor. Okay, so in an automobile transmission, a gear has full depth teeth with a pressure angle of 20 degrees, diametral pitch of unity, a face width of 0.5 inches, and a Lewis form factor of 0.3. The tangential load on the gear tooth is log normally distributed with a mean value of 3,720 Newton and a coefficient of variation of 0.080845. The yield strength of the material is known to follow log normal distribution with a mean value of 32,000 Newton per inch square. Find the maximum permissible value of coefficient of variation of yield strength required in order to have a reliability of 0.999 for the gear tooth. So the question is very simple. The question is you have to find the coefficient of variation. What is the coefficient of variation? Coefficient of variation is a ratio of standard deviation to the mean. Okay, they want the maximum permissible value of the coefficient of variation of yield strength. That is the strength of that particular gear tooth. Okay, but what is the load acting on it? The load acting on is that stress, the bending stress. Okay, because of the bending stress acting on this yield strength of the gear tooth may break or not. Okay, so but the bending stress itself is functionally related to the tangential load through the Lewis equation. So that is what given here. Yes, Ft Pd divided by W into Y. It is simply here S is small s is the load L, and the yield strength is the strength S. And they, from the experience, the engineers know that, or they knew that these two random variables are following log normal distributions. Okay, which are following log normal distribution. The tangential load Ft is following log normal distribution, and yield strength is also following log normal distributions. And here the bending stress is a function of this tangential load, and Pd, W, and Y are constants. So it is nothing but S is nothing but a constant multiple of Ft. So it is again, S is again a log normal distribution, and we can make use of the this property. So now you have two random variables, they are following log normal distribution, and based on the definition which I proposed in the previous slide, we can evaluate the reliability of this particular quantity. And actually it is possible to evaluate numerically the maximum permissible value, the coefficient of variation. So this will give us, the engineer have an idea about how far this particular gear tooth will function, and what is the probability of survival of each of its tooth, depending on the tangential load applied on it. Okay, so that is an interesting example, engineering example in the to evaluate reliability, as well as how the other things can be evaluated. Here this is evaluated with the assumption that you need to fix the reliability as a point, reliability as 1. So we need without failure. So how much coefficient of variation is to be? So the engineers can decide the gear tooth accordingly. So that is the utility of these type of problems, and the methods the methodology we derive. Okay, so I think I'm sorry that I could not go further on the more topics, because plenty of topics I have to. This is only 21 slides I have completed. I don't know how far I have succeeded in imparting this concept to you. If you have any questions, you can ask. If you want to continue, I will continue, no problem.
No, sir, because afternoon they have to start at 1:30. So
okay,
it will.
Okay.
Okay. Is there any questions or comments on this class? Yeah, there is a question in chat box. How can we identify the proper failure rate model for the given reliability data? From Chaco, Dr. Chaco.
Okay. Can you repeat? Identify the reliability function, underlying reliability. It's not I cannot hear, sir. Okay, I think your mic is muted. Sir, your mic is muted.
Okay. How can we identify the proper failure rate model for the given reliability data?
Okay. That is always that's what I'm. The next slides are actually explaining about that, because you have different quantities useful. I mean, commonly used to identify the underlying distribution. For example, the characteristic property of this failure rate may lead to the identification of a distribution. For example, the simplest example is that if the failure rate is constant, it is a characterization of an exponential distribution. So there is no need to search for any other distribution if the failure rate is constant. Similarly, if the failure rate is linear one, then the possible distribution is a Rayleigh distribution, a particular case of the Babel distribution. So that type of characterizing relationship have established, and that is available in literature. So one can utilize this characterizing relationship for identification of the distribution. And apart from that, once you have concluded that this is the possible model, then you have to apply the standard procedure of testing the goodness of fit to check whether the distribution that you have assumed is correct or not. Okay, using the standard procedure of Kolmogorov-Smirnov test, that type of methods you can employ.
More questions? Still, if there is any question, please ask Dr. Sunoj by mail or by WhatsApp or by any mode. Okay, on behalf of all present by online and offline, I express my heartfelt thanks to Dr. Sunoj.
I don't know how far I have succeeded, because
no
I have
problem.
limited my talk to.
Yeah, there's no problem. No problem, sir. Okay, Sunoj, thank you very much. And over to Gautami.
Thank you so much, sir. I would like to extend my gratitude to Sunoj sir and Sankaran sir for their talk. And I would like to thank Dr. P.O. Jensen sir for chairing both the session. Thank you so much, sir. Now we come to the end of forenoon session, and we will resume our afternoon session at 1:30 p.m. Thank you so much, sir.
Okay.
Welcome back. With the spirit, the show must go on. Moving on to our next sessions will be chaired by Dr. T.D. Xavier sir. Dr. T.D. Xavier sir is the retired associate professor and former head of Department of Statistics, St.Thomas College Autonomous Thrissur. I welcome Xavier sir to chair the session. Over to you, sir. Sir,
Yes.
can you hear?
Yeah, I can hear.
So we will start our section right now.
The time is now, it is only 1:30 it is starting. Now I can start now.
Yes, sir, you can start.
Am I audible to you?
Yes, sir.
Yes, the first session by Satheesh Kumar, isn't it? Today we have an excellent speaker, Professor Dr. C. Satheesh Kumar, former head of the Department of Statistics, University of Kerala. He awarded, welcome Satheesh Kumar. Hello.
Hello, sir. Hello, sir. Yes.
Yeah.
Yeah.
Okay. We are starting the session.
Yeah.
Okay.
Yeah.
Okay. Okay, good. Today we have an excellent speaker, Professor Dr. C. Satheesh Kumar, former head of the Department of Statistics, University of Kerala. He awarded his postgraduate degree from Kerala University, and in 1996, his doctoral degree awarded from the same university. He has more than 30 years of teaching and research experience. He has supervised 8 research theses and published more than 120 research papers in internationally reputed journals and edited 2 research level books. And he is a referee to more than 25 statistics journals of high reputation. Presently, he is a member of many national, international bodies or organizations. He is active in many diversified areas. Some of them are probability theory, stochastic process, multivariate analysis, climatology, market research, etc. Today, he talks on a topic titled A Journey Beyond Standard Bivariate Discrete Models. Thank you.
Thank you, sir. Thank you.
Yeah.
Thank you all. In fact, Professor Xavier sir has given a nice introduction to me. Thank you so much for your nice words. In fact, we are let us go without wasting any time. Let us go to our talk. On the outset, also I would like to thank the organizers of this conference, this virtual conference, especially Dr. Anusri and his team and her team, and also so there are several professors are there behind this screen. With your permission, let us have some. I here, in fact, present some of the findings in fact, it is used. My aim is to use whether it is helpful to the research level, especially the youngsters, to motivate them to this area. There is a vast area of distribution theory which is the core area of the statistics. And in distribution theory, we have discrete distributions and continuous distributions and other mixture type, etc. are there. Among them, compared to the continuous distributions, discrete family or discrete type distributions, there is not much research, mainly because of the complexities in the area. And further, there is the bivariate and multivariate situations also require not much research and mainly because of frameworks. But practical point of view, while we are thinking of the practical situations, it is inevitable how to consider such situations. With regard to the bivariate discrete family distributions, in fact, there is very few books are there, especially the Kochallakota, and Kochallakota has a book on is a bivariate discrete distributions. It's a very interesting book. In 1992, they published it. And Johnson, Coates, and Cum, in continuation to that, they are discrete distributions. Johnson, Balakrishnan, and Coates have a multivariate discrete distributions book is there. But bivariate level, not much books there. Even multivariate, that is a very in a crisp way they are presenting that. Bivariate distributions are very important in several respects. You can see it in that book also. And as such, there are mainly we are considering some standard types of bivariate distributions. Here, our interest is to go to the beyond that, these standard bivariate distributions. What happened? What about the situations? Okay, let me to share the slides. Yeah, this is. I hope everyone can view the slides. It's okay. Hello, everyone can view, isn't it? Yeah, view the slide.
Yeah.
Okay.
Very nice.
Yeah. Okay. Thank you, sir. Thank you, sir. I'm not discussing a lot of things here, or not more complicated things. In a very nice, simple way. How to, first of all, let me to introduce some basic families of distributions, in which a Gaussian hypergeometric. I'm just taking a family Gaussian hypergeometric, simply an overview of the work, and thereby generalizing this Gaussian, and then come to the bivariate version. And thereafter, it's how to generalize that family. This is the situation I'm considering here. And before going to that level, it is important to consider the count data models. Why they are important, in fact. While considering the discrete continuous distribution or continuous situation, whatever be this situation, while we practicing in the practical situation, what happens is the continuous variable or reduces to the discrete type, mainly because of the difficulty in the measuring devices. While we are considering time or anything, what happens is we just say the particular times. For example, 210, then 220 or 215, 220, or 5 minutes interval, or 1 minute interval, whatever be, we can reduce to the discrete time. Weight also we can, even though it is a continuous variable, while we measuring the weight, we say this much kilo, 5 kilo, 6 kilo, 7 kilo, like that. So that while considering the continuous variables, due to the difficulty in the measuring devices, there is no need to, in certain situations, the accuracy, but we stick on the particular time points or particular points, so that they erase the discrete type or count data models are thus very important in the practical situations. In fact, it is complicated while considering the count data situations because of in continuous letters we can consider the integral, etc. But here the summation, so infinite sum, other different sums comes there. So computational wise it is quite difficult. But nowadays there is computers and the packages are there, softwares are there, so that these computational difficulties are quite less. So that we can think of such works or research in those areas will be more valuable or important and more practically. The Kemp and Kemp, in fact, Kemp first is Kemp Anthony Kemp and Kemp CD Kemp. They are in fact the same belongs. These two, this couple, in fact, they in 1975 considered the discrete version of the Pearson system through one of their article in an edited volume on a modern course on statistical distributions in scientific work. They considered the discrete version of the Pearson system through this equation, that is MR GR plus 1 minus LR GR equal to 0, where R equal to 0, 1, 2, etc. Where GR is nothing but a probability, that a probability of a random variable capital X takes some value small r. So that this is a probability mass function. In the discrete probability literature, we name it as probability mass function. And here M of R and L of R are simple, some given functions. For example, let us consider M and L are like this. MR equal to gamma plus R into R plus 1 and gamma plus R like that. LR equal to alpha plus R beta plus R into lambda. And such a situation, if we consider here alpha, beta, lambda, gamma, alpha, beta, gamma, and lambda are some parameters, some constants, real numbers that provide the probability. We choose those numbers in such a way that this GR is a probability mass function, so that they consider LR and GR like this. So consequently, they can come up with a GR like this: alpha into alpha plus 1 into etc. alpha plus R minus 1, beta into beta plus 1 into etc. beta plus R minus 1, gamma into gamma plus 1 etc. gamma plus R minus 1, and lambda raised to R by R factorial multiplied by G naught as the solution of this this equation GR. This equation is a difference equation in GR. So GR plus 1 is here. So MR and LR are for the given functions, MR and LR. Here there is not, you have to check. And we consider LR and GR as a particular situations, so that a GR can be viewed as a some constant multiple of G naught. Here this alpha plus 1, alpha into alpha plus 1, etc. alpha plus R minus 1. This is nothing but we can written in a simple form, that is alpha R. Alpha R is in fact in the notation of a Pachamar symbol. We usually say in this way, Pachamar symbol. Actually, by definition, Pachamar symbol, that is AR equal to A into A plus 1 into etc. A plus R minus 1, where R equal to 1 to etc. With A naught is simply 1. So that if you write these terms in terms of grammar simple, this GR becomes alpha R, beta R by gamma R into lambda raised to R by R factorial into G naught. So that the solution of that equation reduces to GR in terms of alpha, beta, gamma, and lambda as the constants, and in as G naught. To find the G naught, what we have to do is the total. We take the total probability. These are probabilities. That is, GR is probability that X equal to R. So sum of R equal to 0 to infinity. Here R equal to 1. Any number 0 to infinity you can take with alpha naught is 1. That assumption you can retain. So that summation of GR equal to gives the answer of G naught, like that G naught equal to inverse of this infinite series. So while taking this taking summation over R 0 to infinity on both sides of this equation, this left hand side becomes 1, so that this right hand side equal to G naught, so that, or G naught inverse we can written as this series, this infinite series, R equal to 0, 1, 2, etc. 0 to infinity, alpha R, beta R by gamma R, lambda raised to R by R factor. In mathematics, there is an area of special functions which is very important throughout in the various fields of mathematics, especially those related to the other areas of physics, astrophysics, etc. And these special functions, this type of a series, infinite series, takes this type of notation: 2f1 alpha, beta, gamma, lambda, and this is known as Gaussian hypergeometric function. So here G naught, the constant G naught, it can be written in terms of the Gaussian hypergeometric function. So that here GR represented in terms of this type of a function, where this is a normalizing constant, in the sense that GR summation over R0 to infinity GR gives the value of G naught, for which if you find the G naught, it is nothing but the Gaussian hypergeometric function 2f1 alpha, beta, gamma, lambda. Please note that if this type of a probability mass function is there, we can come up with the special cases for particular values of the alpha, beta, and gamma, so that this on lambda, surely lambda, alpha equal to minus n. If you take alpha equal to minus n and beta equal to gamma, and the lambda equal to minus p by 1 minus p, if you take in this fashion, then this distribution, this probability mass function is nothing but that of this GR is nothing but that of the binomial distribution. So binomial distribution. So n equal to 1, so if you take alpha equal to minus 1, clearly it is a point binomial, nothing but your Bernoulli distribution. And similarly, when alpha equal to R, beta equal to gamma, and lambda equal to 1 minus p, then this density, this probability mass function is nothing but that of the negative binomial distribution. So that you know, negative binomial distribution is again a generalization of the geometric distribution for when R equal to 1. So that it is trivial that when alpha equal to 1 and beta equal to gamma and lambda equal to 1 minus p, that distribution is nothing but the geometric distribution. So in statistics, among the discrete distributions, these two distributions are very important distributions: one binomial distribution and negative binomial distribution, and in fact including Bernoulli and geometry. Geometry's lot of properties are there, and both of these distributions are clearly simply special cases of this family. And there are not all the members, of course, I agree, but so that you can, once you have this probability mass function, that is GR, it is possible for you to determine the probability generating function. So probability generating function here, it is possible we obtained in this way, that is 2f1 alpha beta gamma lambda t by 2f1 alpha beta gamma lambda, where this is nothing but the Gaussian hypergeometric function, and that I have already mentioned, this Gaussian hypergeometric function. And this Gaussian hypergeometric function is very important function in the special functions, as I mentioned earlier. For details regarding, in fact, there is a book itself, a book on Slatter's book is there. Slatter in 1960, there's a Gaussian hypergeometric functions book is there. And in 1966, a more generalized situation for that, Slatter published a book on generalized hypergeometric functions. Also, the Mathai and Saxena's book on in 73 this also is very important in the literature, even in not in statistical literature or mathematical literature. It is important in physics and related areas also. And Mathai, that is why Mathai and Humboldt, they published special functions of applied sciences, like the 2018 book that is again concentrating on these types of functions. Humboldt is in fact, he is the chief of the outer space science session of United Nations. And Mathai and Humboldt in 2008 published this book, which is very interesting book. And that book also contains several things with regard to this Gaussian hypergeometric function. Here, what I mentioned earlier, Chem Anthony and Chem CD, they come up with this type of a family, and consequently several studies in that respect done by Rodrigo Avi et al. They are from Spain. They are Rodrigo Avi et al. In 2003, 2004, 2005, etc. And consequently, the 2007 in Communications in Statistics Theory and Methods, and several other special cases also noticed. And in fact, binomial, apart from binomial and negative binomial, hypergeometric distribution is very well known in statistical literature, and negative hypergeometric is also well known. And these types of distributions, like a hypergeometric, negative hypergeometric, beta Pascal, Polya, beta binomial, Waring, and generalized Waring. These types of distributions are also members of this family of distributions. It is very interesting to read this book on Rodrigo Avi, Rodrigo Avi's paper 2007. And Rodrigo and other people also noticed that these types of families of distributions are quite relevant in the areas of actuarial science, biological sciences, accident statistics, etc. And these Gaussian hypergeometric distributions permit to model complex data sets with one or two model values, heavy tail and infinite variance, etc. Also, the complex parameters also they have considered. Those have applications in the physical sciences, etc. I'm not gone through those things here. In fact, in Kumar 2009, myself, it's a paper, very simple paper. Our MSc students can read this paper. In this paper, we have we have considered generalized family properties of this family of distributions, Gaussian hypergeometric distribution, and in that we obtain the probability recurrence relations for probability mass function, in which the psi1 is there in terms of the Gaussian hypergeometric function itself. And this relation helps us to derive the probabilities of any order. It is helpful us to compute probabilities. Also, the recurrence relations for factorial moments, and moments are derived there. In case of factorial moments, you can view that Rodrigo Avi et al. In 2003 paper, they obtained a relation, a recurrence relation for factorial moments of this Gaussian hypergeometric distribution in this form. In fact, you can see that this form is not a simple one, but it is a slightly complicated one. But while you consider in Kumar, in this paper in 2000 2009 statistical paper, you can see that this you can see a very simple mu r plus 1 you can find in terms of mu r. Simply you can find, so that there is only slight variability there in this here, and the psi function, Gaussian hypergeometric functions involvement is there. That's only thing. But when we have the computer thing, it is quite easy. Also, recurrence relations for raw moments. Rodrigo Avi et al. 2003 obtained a recurrence relation for raw moments in this fashion, while this statistical paper has gives us a relatively simple relation. Here, mu m plus 1, mu m plus 2, m plus m, etc. in terms of mu r plus 1, like that. But here there is no need, simply mu r plus 1 in terms of the lower terms, but it is relatively simple compared to that. Here m is 0 to r, so there are also several lower terms are involved. In fact, yeah, what we have to what we have done is, Kumar in 2017 considered a more generalized situation, and thereafter we considered about a slightly more generalized form in Kumar 2017A. Here we generalized the family and generalized the Gaussian hypergeometric distribution. My interest is not given the topic as bivariate situation. I'm now going to jump to the bivariate situation for the time being. In bivariate situation, we consider the bivariate generalized Gaussian hypergeometric distribution, and for that we construct the model, these bivariate distributions in a simple model, which is leading to this bivariate Gaussian hypergeometric distribution, family of distributions. Here we consider a non-negative function of this form Pt, in which C is is again a Gaussian hypergeometric function, in which lambda is nothing but a lambda 1 plus lambda 2 plus lambda 3 is an element of the parameter space capital theta, with lambda 1 strictly positive, lambda 2 strictly positive, lambda 3 greater than or equal to 0, or lambda 1 less than 0, lambda 2 less than 0, lambda 3 less than or equal to 0, according as this is a subset of the 0 infinity or minus infinity 0 respectively. Capital thing. Yeah. Now we define a theta j. Theta j in terms of lambda and lambda j's. Lambda 1, lambda 2, lambda 3. So theta j, theta 1, theta 2, theta 3. We come up with a reparametric situation. Yeah. Or we define a parameter theta j or lambda j's in terms of theta j, so that and consider a sequence of bivariate Bernoulli random variables. Here, xn is a sequence of bivariate independent and identically distributed bivariate Bernoulli random variables. That's independent and identically distributed. That also is quite important. And each with the probability generating function of this form, a t1 t2 equal to theta 1 t1 plus theta 2 t2 plus theta 3 t1 t2. So that further we assume that this sequence of Bernoulli random variables and n are statistically independent, the random variable capital N are statistically independent, and we consider the probability generating function of the random sum, that is n equal to 0 to capital N xn, where xn's are bivariate Bernoulli random variables, so that with u naught is 1, we defined for the initial condition situation, and so that the g of t1 t2 reduces to this type of a probability generating function form, in which lambda 1, lambda 2, lambda 3 and psi are the parameters, and also alpha, beta, gamma are there, so that this family of distributions in which c is a constant, which or normalizing constant, which gives which also in terms of the Gaussian hypergeometric function, this formulation is a standard one, so that there's no difficulty. So this family we call it as bivariate generalized Gaussian hypergeometric distribution. Now please note that corresponding to every special case of the Gaussian generalized Gaussian hypergeometric distribution, it is possible for us to derive a bivariate version of that distribution, So already mentioned certain special case of the Gaussian hypergeometric distribution, and thereby I generalized the generalized Gaussian situation, and thereby introducing this bivariate class. This bivariate class is a very rich family in the sense that it is contains the bivariate versions of several univariate distributions which are members of the generalized Gaussian hypergeometric distribution. Now please note that let us for our students' sake, let me to give some as mentioned earlier, one or two examples. Bivariate binomial distribution is quite in Kochallakota and Kochallakota book I mentioned in the initial part of this talk. In that book, one chapter is fully there for bivariate binomial distribution. One of its chapter is fully devoted to bivariate binomial distribution. In the bivariate binomial distribution has the probability generating function of this form, and which is nothing but a member of this bivariate Gaussian generalized Gaussian hypergeometric distribution. In fact, in that book, it is not in terms of the Gaussian hypergeometric function. I'm already mentioned that 1f0 is simple because in the other way you can represent, so that bivariate binomial distribution can be viewed as a member of this bivariate generalized Gaussian hypergeometric distribution. And also the bivariate negative binomial distribution I mentioned earlier. In the case of Gaussian hypergeometric distribution, the same similar type of special cases. Alpha, instead of alpha, I have taken it R, B alpha 1, that is R, alpha 2, and beta 2 are same here, B equal to beta, and lambda 1, lambda 2, etc. like that. So that this distribution is also a member of this bivariate negative bivariate generalized Gaussian distribution. And psi naught is trivially 0, psi is 0. And this family thus includes, I already mentioned, bivariate binomial is a member of this family, bivariate negative binomial is a member of this family, and apart from that, bivariate hypergeometric, bivariate negative hypergeometric, bivariate Pascal. So please note that in Kochallakota and Kochallakota's book, there is another chapter is fully devoted to bivariate negative binomial. And so some other bivariate distributions are mentioned there. Some of them are here, and some others are not here, not in that book. In fact, they are the newer cases, and thus bivariate polia, bivariate beta binomial, bivariate Waring, bivariate generalized Waring, etc. Further to that, this family of distributions we can view as a bivariate random sum distribution. Please note that in Johnson, Kemp and Coates univariate discrete distributions in 2005 book, there is one chapter I hope it is chapter 9, is fully devoted to univariate random sum distributions. One chapter fully devoted to univariate random sum distributions. Here the bivariate random sum distribution is a family of bivariate random sum distributions is we can view it through this family, this bivariate generalized Gaussian distribution. These random sum distributions have a important, in fact, because of their applications in the actuarial science, in biological sciences, physical sciences, etc. So a lot of applications you can found with this bivariate. In fact, univariate random sum structure have a lot of applications. They are mentioned in the literature in several places. This bivariate random sum structure also, this is introduced through our works only. In fact, these are the concepts. And thereby, in our paper Statistics and Probability Letters in 2002, and some other papers in Journal of Korean Statistical Society, Kumar, Journal of Statistical Research, Journal of Statistical Theory and Practice, Brazilian Journal of Probability and Statistics, Journal of Statistics and Applications, Journal of applied statistical science, statistica, etc. So several works are there in that direction, and these bivariate random sums distributions are in particular studied in these papers. Also the GISA paper and Journal of Korean Statistical Society, Metrica, and Economic Quality Control in 2013 paper. So several works are done in these directions already. For the time being, I'm also interested to mention the importance of a particular case or a particular speciality of these types of family, and especially because all the members of this family of distributions are all the moments of this family of distributions exist finitely. So here the product moments are. This is a bivariate situation, so product moments. All moments of all order, product moments of any order exist finitely. So this proved here. I'm not going to the proof of this theory because it is no need to extend or it further. And also the marginal distributions, can see that the marginals of this family bivariate Gaussian, generalized Gaussian hypergeometric distribution are Gaussian, generalized Gaussian hypergeometric distribution. This gives us that this indicates that their marginals are generalized Gaussian hypergeometric distributions. And further, the conditional distributions, if you are thinking of or we are interested in the conditional distribution, you consider let small y as a the y1 conditional distribution of y2 given y1. If you consider y1, y2 as a bivariate Gaussian random vector. So what about the conditional distribution of y2 given y1? I'm not going to the derivation of such results. I utilized the Subramaniam's Journal of Royal Statistical Society 1966 paper here for the derivation of this in terms of the generalized probability generative functions, and it can be viewed as this the conditional distribution of these family can be viewed as the distribution of the sum or the distribution of the sum of independent random variable, say W1 with the probability generative function G13 and W2 with the probability generative function G2 of T. So that please note that this G13 is nothing but the probability generating function of a binomial variate with n equal to y and p equal to lambda3 by lambda1 plus lambda3. And the other part G2 it is nothing but your Gaussian generalized Gaussian hypergeometric distribution. So this can be viewed as the sum of two independent random variables, one following univariate binomial distribution, whereas the other following univariate generalized Gaussian hypergeometric distribution. Okay. Now, these results helps us to derive the conditional moments, expectation of y2 given y1, and conditional variance of y2 given y1 in a simple way, and thereby you can think of conditional distribution of y1 given y2 also in a similar way. I'm not going to those details because those are trivial ones. Once you have the conditional distribution of y2 given y1, it is possible for you to find the distribution of y1 given y2, not a difficult one. And with regard to the probability mass function, once you are ready to come up with the derivatives of the Gaussian, the probability generating functions or partial derivatives of order, and thereby you can. I'm not going to the details of the derivation for the time being, and we can come up with the probability mass function of the as FRS. FRS equal to, this is the C, is the your normalizing constant, lambda 1 raised to R, lambda 2 raised to delta star divided by M factorial, R minus M factorial, S minus M factorial, lambda 3 by lambda 1, lambda 2, the whole raised to M, where lambda star is nothing but product I equal to 0 to R plus S minus M minus 1 delta I. Here, delta I already mentioned earlier. In fact, it is possible for us, for anyone to represent the factorial moments mu rs also in a similar way. And this probability mass function and factorial moments, while we looking into the picture, these expressions may seems to be quite difficult or quite complicated ones. Please don't worry about that. We have the recurrence relations we obtained, which we mentioned earlier, and expected value of y1, expected value of y2, covariance with y1, y2, between y1 and y2, etc. of this family of bivariate family is also one can obtain in a simple way. Those things are not difficult. And already I mentioned that its probability mass function looks like this is some complicated. In fact, this complication is not much a serious one. Why? Because all the bivariate distributions, discrete distributions, you can see in the Cochin-Lakota's book, Cochin-Lakota and Cochin-Lakota books. There, all those representations are in terms of that such a summation series and slight complication there. But it is possible for us to derive or to compute the probabilities with the help of these recurrence relations. Please note that these recurrence relations helps us to derive these probabilities in a simple way. Or you can write a program in any computer programming, or you can use some other packages, softwares. It's simple to evaluate. And these probabilities helps the computation of probabilities of these families are not difficult. Thereby, the special cases are also not difficult. All these results we can reduce to special cases. And recurrence relations for factorial moments also here. Already mentioned that the factorial moment relation also slightly complicated. No, you don't worry about that. You have the simple factorial moment recurrence relation, or recurrence relations for factorial moments of this bivariate family. It is very simple, and so thereby you can obtain also we have, for the completeness, it is possible for us to have the situation. And once you have the factorial moments and product moments, they determines each other, uniquely determines each other. No difficulty to obtain the moments of this family of distributions. And thereby also some more results, very interesting results, because if you have a random variable psi1, which has the probability density function of this form, you please note that this is a generalized family of beta type 1 distribution. And this reduces to the beta type 1 in the simplest situation. And if you consider this parameter psi1 is again so for given values, given psi1, if you consider if the discrete random vector z equal to z1 plus z2 have the bivariate generalized Gaussian hypergeometric distribution with the probability mass function of this form, then the unconditional distribution of z is nothing but a bivariate generalized Gaussian hypergeometric distribution. So once you have this type of a probability density function in which here the density distribution of this psi1 as a generalized beta family, and your random variable z, the conditional distribution of z given psi1 is like this. That is again a bivariate generalized Gaussian hypergeometric distribution. Then the unconditional distribution is nothing but is also a member of this bivariate generalized Gaussian hypergeometry family. So this results in a similar way you can find the a limiting case. Oh yeah, another result is before that, this instead of considering the generalized gamma, it is possible for you to consider Psi1 as a generalized, this is a generalized beta, you can consider generalized gamma, because there e raised to minus psi2, so denoted as psi2. So that this again, in a similar way, this family, the unconditional distribution gives rise to a, or belongs to the family of bivariate generalized Gaussian hypergeometric distribution. Please note that in the limiting case, once you have a generalized, this is a lemma with regard to generalized hypergeometric function. As a consequence of the lemma, it is possible for you to derive this type of a result. The bivariate generalized Gaussian hypergeometric distribution with this PGF is the limiting form of this type of a bivariate, again a bivariate generalized Gaussian hypergeometric distribution of this type of a PGF, in which C tends to infinity. C inverse like that. This when the C tends to infinity. So as a limiting case, this this family includes some limiting case of these distributions. And how now our interest? So there's some special situations are there. I'm not mentioning those situations here. Some more time is there. That is why I am quickly generalize this family. I already mentioned that I have can consider an equation, difference equation, in which LR and MR they have taken in a particular way. I generalize in that fashion. So this is the situation, MR and LR, where GR is, I already mentioned, is probability is equal to R. And earlier we take MR and LR like in a simple way, that is alpha this way. I'm generalizing this situation through considering alpha, instead of alpha equal to here, alpha equal to A1, beta equal to A2, gamma equal to B1, and thereby considering several variables, say A1, A2, etc., AP, B1, B2, etc., BQ. Why? Because in statistics, we while now due to the introduction or the latest theory of data analytics, or with regard to the big data analytics or multi-dimensional scaling, etc. So we have a lot of computational facilities due to the development in the computer science area or computers. The computational difficulties are much less. So any type of data it is possible for us to analyze. And there we require more complicated models, which consisting of more number of parameters, or the number of parameters is not a difficult thing. So it's a better model, come up with a better model. And these parameters, A1, A2, etc., AP, you can fix AP, this P, any number you can fix according to your convenience, or to fit that data in a better way, so that this P, you can find the minimum P for what P it is minimum, or which minimum value of the P that data, or P and Q, in fact Q also there. That data or a particular model from this family of distributions fits a complicated data. You can take that data because of the development in the computers. So that is not a difficult. Several packages are coming. Several things are coming in that respect. So that I'm considering LR and MR like this, so that GR becomes this type of a generalized situation formula. In this, G naught is nothing but, as I mentioned earlier, the total sum gives the total probability is 1, which gives the G naught. So that is a normalizing constant you can derive through the this way. G naught inverse is equal to this type of a formulation, in which A1R, A2R, etc., APR, and B1R, B2R, BQR, lambda raised to R by R factorial. So that this function is the generalized hypergeometric function. So as instead of the Gaussian hypergeometry, we can have generalized hypergeometry function. As I mentioned earlier, generalized hypergeometry function is already studied in several books, including Matthias and Saxena, Slater's book, Matthias and Hubbard, etc. There are several books are there. And in fact, Kemp in say 68 paper, they studied such a family, and that in fact in the univariate situation, that family consists of several members as its special cases, and we have developed the bivariate situations of such families in 97, 2007, 2002, 2009 in these articles, and thereby we derive the generalized situation of the Gaussian hypergeometry through this way, and the generalized hypergeometric function, and we come up with we termed it as a more generalized class, generalized hypergeometric recursive distribution, so that the bivariate situation can derive in a similar way, like mentioned earlier, A1, A2, etc. AP, theta j defined like that, and A1, AT1, yeah, considering it as an independent and identically distributed bivariate Bernoulli random variables itself, so that they are independent and come up with a more rich family, and termed it as bivariate generalized hypergeometric recursive distribution, simply BGHRD distribution. Please note that this BGHRD distribution is very rich class of bivariate distributions. In fact, in Cochin-Lakota's book, there is only few compared to this case. We have listed several members of this family of distributions, including bivariate binomial, bivariate Poisson, bivariate hyperpoisson, bivariate displaced Poisson, bivariate negative binomial, bivariate hypergeometry, bivariate inverse hypergeometry, bivariate negative hypergeometry, etc., bivariate Waring, Nair, bivariate Feller, like that. And bivariate versions of certain families also be derived, like the bivariate extended Kautz family, bivariate extended Crow and Badwell family of Tribadi and Gulan. They have studied that paper work. Tribadi and Gulan's work on the bivariate version of that paper, that work, this family, and bivariate version of the Kemp family, generalized hypergeometric factorial moment family. As mentioned earlier, this wide family of distribution, broad class of distributions or family of distributions also possess the property of all these moments exist finitely, so that it's no difficulty with regard to the moments. Also, the marginals are corresponding bivariate the GHRD distributions. So this bivariate GHRD reduce by marginal cell and GHRD. Also, the bivariate conditional distribution y2 given y1 can be viewed as the convolution of the random variables, say w1, w2, in which w1 is binomial, whereas wt is GHRD. And as I mentioned earlier, here also the probability mass function we derived, and the probability mass function looks like this type of representation, and factorial moment relation also there, factorial moments, and similar types of the works, expectation, covariance, etc. are derived, and recurrence relations also obtained. Recurrence relations are not much difficult. These relations helps us to derive or compute the probabilities of any order. Also, recurrence relations for factorial moments we obtain. Those also helps us to derive those relations. And recurrence relations for raw moments, in fact the product moments, and the mixtures and the limiting cases of these families are also going. And in fact, a particular, for example, bivariate Poisson as a limit. But in this case, in the earlier situations, there is not much. Some members are not members. belong to this family. But here, almost all members, more than 100 bivariate discrete distributions are members of this family of distributions. For reference, you can see some of our papers published, and in fact, they are available online. If you want, those who are interested, you can go through these papers. Since there is nowadays 2:24, just concluding my talk here. 5 minutes for your, in case if you have any doubts or any clarity needed. I'm waiting for your eagerly waiting for your comments or suggestions or your doubts. Thank you all. Thank you so much for your patient listening. And once again, thanking the organizers of this conference and the chair also. Thank you all. So
Thank you.
thank you, sir. Yeah.
Thanks. Hello.
Hello. Yes. Yeah. Please.
Yeah.
Xavier, sir. Please.
Thank you for your nice presentation. That is a very good one. Anyway, I don't know whether any scope for participants interaction nowadays.
Yeah. You can email also.
Is there any? Yeah. Yes. Thanking your thought-provoking session. Anyway, this will instigate many of the students or professors to do research in the new era of for new frontiers of bivariate discrete models. Thanking for sparing your valuable time for a invited session of our institution, and thanking once again personally as well as for our coordinators of this seminar. Thank you, sir.
Thank you, sir. Thank you for chairing this session and allowing me. And once again, thanking all of the organizers, including the college management, college principal, academicians, all those attending this session. Once again, thanking you all.
Okay.
With your permission, I mute this.
Yeah. Thanks. Hello.
Hello.
Muralidharan sir.
Yes,
quite welcome. Your video is not to the frame. You please type the frame. And you make some arrangements for your video.
Okay.
Yeah.
Can you see now? My cam is on. Cam is on.
Yeah. Okay. You are seeing. You are seeing in your video, but you adjust the frame. I think you can see the. Yeah. Adjust the frame.
Okay. I'm just opening my presentation.
Okay. Yeah.
Okay. So let me see what it is. So please allow me. Please allow me to do the.
Now I introduce you to the audience.
Okay.
We have Professor Dr. K. Muralidharan, Department of Statistics, Faculty of Science, Maharaja Sayajirao University, Baroda. He is the former head of the Department of Statistics. He is also an adjunct faculty of IIT Gandhinagar since 2012. He awarded his PG degree from Calcutta University in the year 1987 and a doctoral degree from Sardar Patel University in 1996. He has 28 years of teaching and research experience and has guided 7 research students and more than 130 research publications in his credit. Presently, he is in many internationally acclaimed publications, editorial board, including the Journal of Indian Society for Probability and Statistics. Today, he is presenting a session on a topic titled Lean, Green, and Clean Sciences for Sustainable Development and Quality of Life. Thank you, sir. You can start.
Thank you very much, sir.
Yeah.
Thank you very much, sir.
Thank you.
Good afternoon to all of you. My presentation is on in PowerPoint mode. Can you see that? Can you see my presentation?
Yeah. These are very nice slides. Okay.
Okay, sir. Thank you very much.
Thank you.
I'm right now in the second page. Can you see the second page?
Yeah. Yeah.
Okay, then fine. Excellent. Thank you. So thanks to the organizers, Madam Anusri, then Chaco, Professor, and of course, Xavier sir for chairing the session. Also the management, IQAC cell of your college, institution. And yes, I don't know how far this presentation is going to be useful for, because statisticians in Kerala has an habit of listening to technical oriented presentations. So I'm sorry to say that this is not going to be a technically oriented presentation. I completely avoided the technicality from this presentation. Now, okay, so I believe everything in excess is a waste. I do not know how many of you support this claim. I feel and I believe and I follow and I practice that anything excess is going to be a waste. So to have everything in controlled way, I always try to be under a low profile and I use everything in minimum amount. So I hope this is going to be true. Let's see the presentation. Presentation will also give you some insight to this particular belief. Okay, now when I say everything in excess, what do you mean by everything? So the first thing comes to our mind is food. That's what people always think of, food. So I mean everything that means food, water, right, energy, infrastructure, facilities, transportations, everything comes under that. So I feel that everything is going to be a waste, and that is what is the relevance of today. We have to identify what is that, everything and all those things. Okay, so let us move on. There's some story behind this. Okay, let me introduce my book, which is going to come very soon, published by Springer Nature Singapore, and the book is titled as Sustainable Development and Quality of Life Through Lean, Green and Clean Methods. You may be thinking, how come I got into this kind of issues and these kind of problems where it looks all non-technical? Yes, of course, I could say that this is not fully, non-technical. I'm not fully technical and fully non-technical. I could say roughly 50% of each. Now, the reason why I got into this particular topic is because, yes, I did some research, and over and above, in one of our administrative level meeting in the university, I was introduced, or I was told by my seniors that I should introduce some course for undergraduate students. We should be appealing to all. We should be, acceptable to all, and all streams of students should be able to attend, and should be interesting and plus timely. If I put it in quotes, it's very, very important, because the time relevance is very important. So I have my own work. I did this work for last 10 years. Not in a very serious form. So it's ultimately this became a compilation of my own work with some literatures, which my lecture notes and training materials, which I consulted for many companies in Baroda and in other parts of India. So Bangalore, Hyderabad and all. So this is actually a resultant of all those. So now we have already introduced this course in the name of, the course name is already in the name of Lean, Green and Clean Sciences. Okay, it's already introduced for our students of undergraduation here. We have undergraduation as well as post-graduation. So we are offering this as a 3-credit course for this course. So it's right now it's offered as foundation level course, where all streams of people who are coming after 12th education, they can join for. So of course, I'm getting a lot of good reviews also for already started coming in now. And this particular book is going to be the reference come textbook for the same course. Okay, so you can get all the details in the website also of our university. Okay, now the book is under production. Very soon it will be coming. Okay, so what I'm going to show you is some presentations, some slides where it's going to be bits and pieces, because I cannot talk all in one hour time. That a lot of things are there. There are about 10 chapters, all about roughly going to be around 450 pages or something like that. Okay, so with that aim, with that objective, let me put forward some facts and figures in front of you. So my idea is that I have given this presentation not in the same form, because that time it was not in the completely conceived, actually speaking. So I have given, I think, 2-3 places I have already given this talk, and I received an excellent review from that presentation also. Yes, in fact, if I recall very correctly, I did this presentation in the, not this presentation, other presentation in Cochin University of Science and Technology also. And if I recall very correctly, I had 2 visits to St.Thomas College, Thrissur. During my first visit to St. Thomas College, I think I have mentioned somewhere that I am working on this kind of concept, and very soon this will be realized in a book form or something like that. So I think this is the right time. Although the book is not out still, but still I found this is the best place where I can, because this conference is also organized on behalf of IQAC cell of your university. So internal quality assurance cell. So I am going to talk about quality per se. Let me tell you very frankly. So this whole presentation is on quality. Okay, how to improve quality improvement. How do you look? How do you perceive? What is quality, etc. So what is that which can be used for improvement in quality? Okay, so we have seen it all. We have seen a lot of things in the past. In Kerala also, we have seen a lot of tragedies and a lot of problems related to flood, related to many environment and climate related problems. Okay, so a lot of things we have seen. Okay, so landslides, for example. Okay, that's very common in Kerala, for example. So this is another place where you can see tornadoes. Okay, glacier melting, ice melting, water level rising. Okay, volcanoes, and all kinds of things we have seen, and we are still facing, and I'm sure a lot of things are going to come in future also. There is no end to it. Climate and environmental issues is going to be the serious problems in future. Okay, and this is going to aggravate, because we are harming the environment like anything. A lot of things are changing. Okay, we are putting everything for our benefit, harming the environment and climate, and just to a great level, you can say. Okay, so a lot of problems we have seen, and the latest to join is the glacier melting in Uttarakhand or something. Yes, in the north part of India. And you know the problems created. As an end result, what extent the problems are going to be. Okay, it's not only the property loss, it's not only the human lives property, a lot of things, environment related, plants and trees, and things are going out of control. It's all human made to some extent, we could say. We are responsible for it. Okay, so there comes the importance of lean, green and clean concepts. Okay, so that's where the reason why I had shown some of the clips, because I wanted to sensitize this issue. Lean is defined as a set of management practices to improve efficiency and effectiveness by eliminating waste. Okay, eliminating waste. I would be rather often speaking about waste. How do you control waste? What is waste in general? Okay, so I have already given in my second slide that everything in excess is a waste. So please note, from that spirit only I am moving ahead. Lean is actually a term which is usually used for improving quality, increasing the process speed, eliminate waste, reduce variations, and improve the quality. While eliminating waste and while eliminating the variation, it is expected that the quality will be improved. Okay, so lean concept is not very old as well as not very new. So it's all started by Toyota manufacturing system, the Toyota people rather, Toyota. Okay, you know they are what kind of products they are into. Okay, so lean is actually a set of management practices actually to improve efficiency and effectiveness of by eliminating waste. You can improve the efficiency of processes, products, services, okay, or transactions. Okay, we are into all this kind of business these days. You know, education institutions, we transcend. We are into service field, so we do a lot of. We also have inputs, we also have outputs. When you talk about process, so y equal to f of x, we always talk about. So what is this y equal to f of y independent variable x is y is dependent variable and x's are independent variables, and the relationship connecting this y and x is f of x. That's what is called the process. In the business language, that is what is called the process, f of x. Okay, it can be linear, non-linear, any form you can talk about. So how do you improve the process? By improving the inputs. So if you improve the inputs, x's, you can improve y, output. Okay, so a lot of scope for, a lot of statistics and a lot of engineering concepts are there behind lean concepts. And the core principle of lean is to reduce and eliminate non-value adding activities and waste. Okay, it does both. Non-value add, identify all the non-value added activities in the waste. That's the best way of removing, removing the variation from the process so that you can improve the quality. Green, of course, we all know that's color of life. It's color of life. So if you look at the dictionary meaning of green, you can see that it's talking about growth, harmony, freshness, safety, fertility, and environment. It's all about green, color of life. We all want to make it color, green. Even government administration is now very serious about making everything green, green services, green corridors, green transportation, green products, green services. So going green means to pursue knowledge and practices that can lead to more environmentally friendly and ecologically responsible decisions and lifestyles, which can help protect the environment and sustain its natural resources for current and future generations. Please know, we are always said we have all the facilities. Look at the generations to come from now. Look at the new generation guys. Everything is new. Lifestyle has changed. New requirements are coming up. We have our changing needs and preferences changing every now and then. How are you going to sustain? How do we sustain? That itself is a very big question. Okay, so all resources and all facilities, all whatever we have in our earth, in our environment, see, it's for all. Water is for all, not only for our generation or the next generations, generations to generation. How are we going to pass on the what things? Okay, so this is where the issue comes: greenery, greening the business, greening the things. It's all together, green and clean. All talks about how do you make the life sustain? How do you make the product sustainable? Okay, how do you make the product quality based, quality oriented? Okay, and lean and green automatically. When you have the process with the lean and green already inbuilt, then definitely it is going to be a clean business, clean product, clean service. Automatically it becomes. So that is the reason why this kind of concept is very important. We are supposed to be concerned about our climate and environment, and that's itself is the motivation behind writing this book. Okay, so I, being a statistician, I used to be technical. I used to write. I used to have all types of theorems, derivations, etc., etc. But still, I got into this because there was a requirement for one of my students also that for PhD entrance and all those things. So a lot of requirement actually changed my mindset. Okay, and I found that there are a lot of issues which we can also address. Statisticians should also, in fact, statisticians should come forward to address these issues. Otherwise, these issues are generally with management or psychological education or this kind of people they talk about. Social science people generally talk about. I feel that we should also talk about these issues, quality of life. That's the talk I am going to have on a later part. Okay, in few slides, I will talk about sustainability and quality of life as well. So keep environmental impact low and improve efficiency in every organizational process. Keep it balanced. That's very important. Every organizational process. It can be a manufacturing process. If you talk about a very big company, talk about a lot of issues there. They come up with all kinds of emissions, pollutions, and all kinds of noise, gas, chemical pollutions. And you look at the way they are polluting the environment. Air quality itself is a very big question. In many cities like Delhi, Kolkata, Bombay, for example, air quality is now diminishing every day. People have to live. People have to sustain. Okay, you may live for 50, 80 a year. Now the average age has improved because of quality of life, no doubt. Because of quality of life. At the same time, we have all these kind of threats also in front of us. So how are you going to provide sustainable services, sustainable life? That's the most important. That's the motivation behind getting into this kind of field. And to increase attention on environmental performance of the organization and to become sensitive towards climatic conditions and harmful emissions. Please note, I have done a lot of statistics in this particular, as a project only I started with. Okay, a lot of quality dimensions. See, I told you I'm going to show you some bits and pieces from different chapters. So somewhere you may find that is not connecting to or something, some communication may be lost. But please, I tried my level best to give a connection between all the slides here. Lean, green, clean. If you look at many products and services, you can see all this. All these three components are there in all everything, especially the new generation products. If you see, for example, let us look at these products. New generation products. Look at drones, mobiles, LED bulbs, pen drives for us, noodles. See, all types of products. Food products are also there. Consumer products are also. Usable products are also there now. Okay, just for example, drones, for example. A new generation item, which electronic item, which is used in every purpose nowadays. Okay, it started using by this defense people. Now they are into agricultural production. They are using drones. Are used in this thing. Now look at the product as a whole. What is it? It's a very simple product. Simple technology is used. Okay, and the work done by these drones is very efficient, very effectively. Many things you can do. Very small size, doesn't need any long space or we have a very large space for. Very small instrument, very effective drones. Even you can talk about robotic machines, for example. Please, the way you see the artificial intelligence and machine learning, deep learning techniques are now integrated into machines, and things are now working. Drones, it's a very good example. There is a lean component, there is a green component, as well as there's a clean component in that. I will go back to the previous slide again. Look at the pen drives, for example. We all are familiar with pen drives. Okay, some 10 years ago, what was the situation? We were using floppy disks. Then it passed down to CD drives, ROMs, for example, then DVDs, then came portable hard disks and all other kinds of instruments. Then came the pen drive, 1 GB, 2 GB, 4 GB, 8 GB. Like now it's 256 GB, pen drives are also. You please understand the size of floppy some 10 years ago. And the pen drive, the size of the whole. You please see that the lean component, lean. The dictionary meaning of lean is to make it thin, make the process thin, make the process simple, thin, humble, and everything. That's what lean says. Okay. So pen drives, for example, it doesn't consume any space, and what efficiently it does the job. You can store a huge amount of data in a pen drive. Just imagine. We used to have DVDs. We used to have this thing. 2-3 films which to save in a DVD, and that instead of that you can now save 10 films in the whole size. You can save it in a pen drive. That's possible. Okay, just imagine. So lean component. Noodles is all time favorite and everybody's favorite food. For example, see, I'm not promoting the consumption of noodles. My aim is not that. Please see what is the lean, green, clean, and components in the product called noodles. Very simple, tasty, flexible. Okay, can be consumed in a very fast way. It needs less energy for preparation. And energy, when I say energy, means can be electric energy, can be stove energy, gas energy, can be anything. All energy forms. Look at all energy forms. Okay, so look at now again going back to the same slide. Lean, green, clean components. If you see, so that's where we have to focus on. How do you make the product simple? How do you make the products having lean components, green components, and clean components? It's all very important these days. And the products are coming up these days. Okay, so quality flow diagram. So for quality, there should be a commitment. Definitely, it should be timely. That's where people are now looking for. We want everything in timing. Okay, we want everything in promptness. Okay, look at the way people, I mean, the online marketing institutions are doing their job. Amazon, Flipkart, etc., etc. Look at the way the courier service like DHL, FedEx, and Blue Dart, etc., etc. couriers. How promptly they do their job. Leadership, of course, you need leadership also for bringing quality into the organization. Commitment, cost, of course, should have less cost. Yes, being green clean is such a philosophy. It's a philosophy rather. It's a philosophy which is going to give less, and under less cost, you can have the maximum product produce. Okay, so somewhere I had mentioned value-added and non-value-added activities. Quickly, let us look at that. So what do you mean by value-added? Anything which transform the product, service, or in a transaction in a way that is meaningful to the customer. Please note, something should be valuable to the customer directly, not indirectly. Okay, when I say indirectly, for example, simple example, you do examinations. This is what we are talking about, academic people, students, and these things. Okay, so you do supervision duties or invigilation duties, for example. Now you tell me, how does it contribute to the students? Your customer, your customer is student, for example. As such, there is not contributing anything. Okay, so but we have to do, no doubt. Now, can you devise a plan? Can you devise a method where you don't need as invigilator in physical form? You can do the invigilation through CCTV surveillance or cameras or those things. Ultimately, your job is to do that. Whether the people are doing it correctly or not, without any malpractices, etc., etc. Just imagine a method. Okay, how does it is not adding value? It's a non-value added activities. I feel from my experience, I feel they are all non-value added activities. Okay, even the appointments, training, I would say they are all non-value. They are not directly adding any value to the customer. They are indirectly adding, no doubt. Similarly, I think I could give you another interesting example. Okay, we all you see a person, a security guard in front of a ATM machine, for example. What is the job of that guy? What he can do in case something goes wrong with the machine? Can that guy fix the machine? I don't think. That means he's not adding any value to the customer. You as a customer, you are going to the ATM machine for withdrawing or taking some service of that particular bank. Can be a withdrawal, it can be a deposit, or it can be something else. It can be change of PIN, can be anything else. There are a lot of services offered in ATM also. My simple question is, can the guy fix that security guy? Why the guy is sitting in front? Even to round the clock, 24 hours, 8 hours, there will be a change of the person. So what I mean to say is, can't you reduce the job, the job of a security guard? He's not adding any value. It's, of course, if he's adding any value, I don't think a security guard is a man is required in a bank at all. The person always hold a rifle and just watch here and there. What is the use of it? For that, if you want to avoid that guy, you should devise a plan so that there should not be any kind of problem, so that you can have safety, security, keys, alarms, etc., etc. In case something goes wrong, that's enough. You want to alert the person, you want to alert the police, you want to alert the people responsible to curb the menace. That's what you have to think of. Okay, reducing the people. Please, my point of word is not to decrease the employment opportunities or anything of that kind. So please note that. Okay. So what I feel that there are a lot of non-value added activities. Many of 95% of the time it is going to be non-value added activities. Look at government offices, for example. Government office, almost every government institutions. You may feel that, you may think that even Kerala, the administrative jobs and everything is okay, the people may be, but not all people are not doing their job. Some people are doing, that's right. Some people are very committed, focused, and they do their job and all everything. But rest of the time, the others are simply sitting and they are simply idle, and they don't do the job as per, the requirement. So activities that add no value to the processes are called non-value added activities. When I say process, it's a general term. You should always see from an optimistic point of view. Okay, please look at the process, the name in a broad sense. So NVS are those activities that are required by a business to execute work that adds no value to the customer, but still they are willing to pay for. Okay, so you may in academic institutions, so you may need appointment, you may need to conduct trainings, you may need invigilation, etc. But again, find the value behind that. Okay, so here is a simple diagram. Okay, you can see that waste, we always talk about in operational research courses also, we talk about 7 waste, 8 waste, etc. Transportation, over inventory, excess inventory, motion of people, motion of materials, motion of files, for example, motion of files, okay, etc. All these are going to generate waste. They are all going to be non-value adding as such. So in a general setup, if you see 95% of the time, they are going to be non-value added activities. And to have quality in the process, you have to decrease the amount of non-value adding, and that decrease should reflect in the value addition, so that you can so that the waste also will be less, and automatically the quality of the process will increase. Okay, and at the same time, when you talk about these waste generation, etc., and the value added and non-value added activities, we'll have to talk about what is the cost of quality and cost of poor quality. This is also very important. The assessment of this COQ and COPQ will guide you how much you have to invest in a process. If you feel that the investment is going to be very huge, if it is going to cost the company or the organization very badly, I think you should stop going for or looking at that process. That's very, very important. So the cost incurred to ensure the quality is maintained at an acceptable level is called cost of quality. You can compute cost of quality statistically, mathematically, even financially also. Okay, a lot of formulas and a lot of things are possible. Okay, and this code of is already possible. It's every time it is possible every time. For instance, the inspection process is done routinely, as I told you, invigilation and the supervision duty, for example. So this just like that, inspection is done quite often. In the manufacturing process, inspection is done by somebody. Okay, in a lot of incidents are happening in Kerala, for example. Okay, in investigations, for example. Now, there are a lot of unnecessary investigations. Lot many in the recent this thing. Anyway, I don't want to comment anything on that. I am not a politician at all. But still, what I mean to say is there are a lot of waste and money simply for doing an investigation. That too from the exchequer of finance of the government, and that finance is coming from the public. It's a lot of waste. Lot of money is wasted. For instance, the inspection process is done routinely to see the performance of product and service quality again and again. One person comes and goes. Second shift, again the same inspection is done by somebody else, the third person. Again to see whether the first guy has done the same correctly the inspection or not. The third guy will come and see. So this is costing the company a lot. It is generating poor quality materials, as well as it is going to cost a lot of time and infrastructure for the company. However, the cost associated with the inspection is generally not accounted in figures and numbers. That's the reason why I'm telling. They are not generally counted in terms of numbers and figures. So they should be avoided. And the cost incurred to correct processes that fail to perform as intended is called cost of poor quality. So this cost of poor quality will be many often more than cost of quality. If that exceeds, I think the organization is gone. So to increase the VA activities, you have to decrease the COPQ. Okay, so less the better. Okay, so this is how, for example, if you are talking about industrial sectors like manufacturing, production, automobile, service, for example, a lot of failure cost we could talk about. No, in statistics also we talk about reliability concepts, and we talk about a lot of availability, maintenance costs, etc., etc. So if you see, 50% of the time it's going for internal quality failures and external quality failures together. Internal and external, just quality failures, please note, which can be improved and which can be converted into profits. And whereas appraisal cost, efficient process, cost of efficient, inefficient process, prevention cost, hidden cost, etc., all constitute rest of the 50%. But first, the quality related cost can be definitely converted if you have a focus approach. It's not very easy, but you should focus on. But generally people don't have that patience to. That's the problem. Management doesn't have that patience to. Okay, they know if it is going well, fine, let it go. Let us see where it is going to fail. they will wait for. This is what is happening. So this is a problem with the problem. That's where we need to focus on lean, green, and clean concepts. So let us quickly discuss some green sciences. Then I will talk about some green technologies. I don't know. I have been given 1 hour, so let us see. I will try to. You can stop me at any point of time, so I don't mind. I hope I am audible to all of you. Can one of you respond, please? Am I audible? I forgot to ask this. Hello? 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 Nobody is responding.
Sir, you are quite audible. We are all patiently listening you, sir.
I see. People are patiently listening. Okay, I'm really worried actually. I'm not getting any response. At least one. Okay, thank you very much.
Audio is a very good quality, and you can continue now.
Oh, okay, fine. Now I will not ask you. Thank you very much.
Thank you.
Okay, so we'll just discuss about green sciences. A lot of green sciences are nowadays discussed, practiced, experimented. Okay, some of the terms are familiar to you also. Some of the terms are very, specific to management. Okay, some of them are, introduced. For example, green strategy is a concept introduced by us. Then green supply chains. I'm contributing to some green supply chain management, and green statistics supply chains, etc., etc. These are some of my study area nowadays. Okay, so I'm sure you have heard of it. I'm not going to talk about all this. I request all of you to read my book once it is out. Okay, all these concepts are discussed in detail. Okay, so let us quickly go through some of the things related to this one. And okay, the LGC initiative facilitates best business practices, cost-effective products and processes, sustainable thinking and practice. Change your process, change your thinking process. Look at your future generations. Now we have to have everything, every service, every products, everything we have to look for our future generations. Our parents, okay, fine, their job, their life, their innings is over. Now the coming generation, the next generation, you just look at. You see, the next generation is going to live for 100 years on an average. The life expectancy is increasing every day, every year by year, you can say. The next census is going to give a lot of wonderful, exciting inferences regarding the expectancy, life expectancy, etc. It's already 70, 72 now. It's going to be somewhere around 80 for this generation. Now you can imagine the next generation is going to be, okay, sorry. Definitely you're going to live for 90, about 100 years. Just imagine. So how do you go how the future production all should be addressed to them now? Okay, so you have to increase the sustainable thinking and practice as well. You should also improve the collaboration and mutual participation. Okay, it's happening. You are familiar with collaborative research, collaborative assignments, etc., etc. Now collaborative products, between nations, between states, between countries, it's very, very important. You have to improve, you have to increase the collaborations now. Waste treatment disposal, you have to make it a common practice. You just imagine how much waste is generated every day, that to plastic waste, for example. Now local administration is also trying to collect the waste generated at homes, each homes. You can imagine how much it is going to be generated. Everything is going to come in cartons. Everything is completely in cupboard, etc. Okay, you have a lot of papers, you have a lot of plastics or something, some way the waste is generated every now and then. So just imagine. How are you going to dispose it? That's a big question now. Electronic waste is increasing like anything. Japan, for example, Japan and China, for example, they are facing the the challenges from electronic waste. All items they are the giants, for example. They are the people who are bringing all the technologies, new, innovative features, etc., etc., in the electronic items. So they are facing. Even India is also going to face the waste from electronic waste related issues in future, and there should be increased concern of future generations and livelihood. And above all, one should also try to reduce greenhouse gas emissions, GHG. Okay, greenhouse gas emissions. Another important thing. People are now centered on this. Many research and many studies are now focused only to see how much is the contribution of GHG. GHG can constitute many things. Okay, water vapors, methanes, carbon dioxide, nitrous oxide, and the ozones, etc. It's a combination of 5 chemicals. Just imagine. Some of them are very, very harmful. Okay, carbon dioxide is no problem. More the better, no issue. But the other chemicals are harming the environment and climate. So how are you going to control? Because every production is going to have, every house, for example, you see the amount of energy consumption in a home. Okay, lot of energy, lot of waste is consumed. See the number of mobiles are charged every day, and the whole night. In fact, a mobile needs only 2 hours charge for 100%, but you charge it for the whole night. Okay, not 1, 2, 3. There are 4 members in the family. All 4 members' mobiles are on charge. Just imagine TV, AC. AC is now common everywhere. Once upon a time, it used to be a luxury item that to seen only in big upper class families. Now it's everywhere now. See the amount of charge, amount of electricity used by, not even generated. You are not generating anything. Okay, and see other instruments in electronic items in a home. How much radiation effect? How much effect? A lot of harmful substance is produced by all these instruments. Okay, so please take a note. India ranks among the top 4 emittents of greenhouse gas emissions worldwide in aggregate terms after USA, China, and Russia. You please know that. Okay, India is still a developing country, not a developed country, but still India is going to take over from all this. Okay, and according to some estimate, China will increase the world's CO2 emissions by 39% by 2030. In just a few years, it is going to be like that. It's already overtaking USA emissions in 2002. This is the situation. It's growing, very harmful, and should be very concerned also. Okay, let's talk about some technology issues. Okay, details, some statistics, figures, everything is given by book. Please refer to that. Okay, so a lot of other issues, a lot of techniques through which you can reduce the effect of greenhouse gas emissions, etc., etc. So also discuss them. Okay, so I'm not discussing here, so I don't have the time to discuss all these things. Okay, and the main purpose of green technology is to slow down global warming and reduce the greenhouse gas effect. And the main idea is the creation of new technologies. And that's why the government is trying hard to educate people, especially the school, the college and university students. The college university students should also initiate something for reducing, supporting the environment at least. Okay, there are ways and means, and these days new generation guys are very smart. They can play with the internet, they can play with the new technology much better than the people like us. We are very poor at. Okay, I think these people should do, and they are doing. A lot of initiatives are there from central state governments also, so one should be a part of it. And this should result into a less harmful to people, species, and general health of our planet. Otherwise, it will be totally imbalanced planet. You can see all kinds of problems. Everything is uncertain now. Okay, the glacier melting in Uttarakhand or Chhattisgarh, I think it was completely unexpected. Okay, people doesn't have the time to think of what to do, whether to run, whether to stay back, or what to do. No movement was possible. Everything happened all of a sudden. That's what is happening everywhere. Okay, in Kerala also we have experienced all kinds of flooding and landslide. Okay, nobody is not giving any time to think. It's completely uncertain. So okay, a lot of issues are the statistical study you can address on these kind of issues. Okay, so planet is completely imbalanced. Anytime, any side you can turn. If that is the case, disasters will come, and that's what is happening. Some examples, for example, you can have wastewater treatment. Of course, some of these things are already there. Many people, many organizations, many NGOs, and many state governments are promoting these kind of issues. Okay, I'm not suggesting anything new, but there are few things which you can do. Okay, you might have heard of road manufactured from rubber, for example. Rubber technology can be used for road manufacturing, so that the grip can be increased. And that too in Tamil Nadu, somewhere around Erode or somewhere connecting some road. They already prepared. So experimentations are going on. There are many wastewater treatment plants, for example. You might be knowing, even IIT Bombay, they have introduced a plant only to process the waste food. Okay, Number of students are studying. Food waste is generated. Food waste is something very, very important. Okay, in everywhere, in every house, for example. Okay, till a few years ago, we all have something to eat. That's all. We were having only limited things to eat. Okay, so never ever we had any waste. And nowadays, every day our stuff is different. And every day we are eating different things. Sometimes in, sometimes out. See the amount of waste generated by. See the amount of food waste generated by restaurants and big hotels, for example. How do you treat where do you dispose it? Disposal is a very question. Now that again, how best you can transform that into some energy form, and that is where the people are now looking for. Okay, you can have wastewater treatment, waste food water treatment, etc., elimination of industrial emissions, reducing, recycling and waste management, self-sufficient buildings. Self-sufficient buildings. This is what now the focus of local administration. Okay, many Western countries have already done this, self-sufficient buildings, where everything is generated there itself. Solar panels. Most of the buildings are now going for solar panels. It's a very good idea, no doubt. Okay, it is regenerative type of. Okay, a sustainable product. Okay, you don't need extra these things. You are using sunlight for generating electricity. Okay, waste to energy. Convert waste into energy. Generation of energy from the waste. So in the example which I told you, the IIT guys, Bombay, they are generating energy for all their purpose. And ultimately it is also used as minerals for trees and plants and whatever they do it in their campus. Many campuses are doing that. Many campuses are doing now as a replication of that. Vehicles that do not emit gases. Yes, that's the reason why we are talking about electric vehicles now. Now the future vehicles are all going to be electric charged. Harnessing solar energy. Okay, do all these things, etc. Okay, clean energy and some sources. Clean energy is energy that comes from renewable, zero emission sources that do not pollute the atmosphere when used, as well as energy saved by energy efficient measures. And that's where what is called clean energy. And there are a lot of sources now. It's possible. Okay, you can regenerate, use the same energy to generate another form of energy. Okay, so that's what the solar panel is doing, especially. Okay, and you can use solar energy panels, wind energy. Yes, turbines. You can use wind energy panels are now established. Many. I mean, at least on the coastal side, you can see wind energy panels established. Bioenergy, geothermal energies, hydropower. Yes, of course, you can directly generate energy from the sea waters and the river waters, etc., etc. Of course, natural gas, and there are many ways you can generate. Clean energies. Please see the name clean. We know how that clean comes. So it's again by making clean and green, you can make it clean energies. Okay, there are some improvement models I am talking about. Okay, a lot of improvement models are discussed in my book. Okay, of course, there are some of the terms you are already familiar with: total quality management, total productive maintenance, Kaizen approach. Kaizen approach is a continuous improvement. Kaizen is a Japanese term called continuous improvement. 5S plus safety and security techniques. So safety and security is something which I myself added to the 5S. 5S is a very important management concept. It's also talking about sorts, set in order, sustains, straighten, etc. So it's also a Japanese term. Japanese term is equal to Shiso, Shiketsu, Siri, Shitsuke. It goes like that. Okay, so it's actually a philosophical way of improving the things, quality of the atmosphere, quality of the environment you live in. Okay, office keeping, for example. Okay, very interesting, powerful, and very easy technique, where you can generate a lot of cost of investment you can generate from that. 3M techniques. 3M, Muda, Mura, Muri techniques. Muda stands for waste. Muri means unevenness. Okay, Muda, Mura, Muri means inconsistencies, etc. Pokai, mistake proofing, setup reduction, just-in-time approach. Some of the techniques are discussed in operational research papers also. Kanban, workplace management. Kanban stands for workplace management. Six Sigma concept, of course, is a very big concept, very important philosophy of all this. In fact, I would say all the above techniques comes as a part of Six Sigma philosophy, quality improvement philosophy, where I am a Six Sigma master black belt, and I am a quality trainer, internationally certified quality trainer from Indian Statistical Institute, Bangalore. And capability maturity model integration is another technique, etc. There are improvement models. Then there are many assessment models also, which we have introduced. Some of the models we have introduced. ISO 9000 series, of course, you all know. We know that it's so used for quality improvement. They are all guidelines actually, how to proceed with. That's all. Guidelines for promotion of product, service, manufacturing, etc. The guidelines to follow by the industries, etc. etc. Okay, there are a lot of series available in 9000. Okay, it's a series of quality guidelines. Environmental management system, generally talked by this management guys. Eco management audit scheme, another scheme where you have to audit all these issues related to ecological management. Okay, issues related to environment and ecology, biodiversity, ecosystem, etc. Then, of course, corporate sustainable business, very important thing. These days, many people are going for. In fact, all companies are supposed to get into corporate sustainable activities. They have to promote the business activities, or they have to extend their business activities to the poor people or people who are needy, or they have to contribute some percent. At least it is said that 10% of their profits should be shared with the common people. Some way you can initiate some program, you can collaborate with the institutions, education institutions, you can collaborate with other institutions where you can promote their own business and promote other business, etc., etc. Okay, uplifting the poor people, that's the main focus behind this corporate social activities. Then occupational health and safety assessment system is very important for health management and all the safety management. So they have to follow, there are also guidelines, for example. Emission auditing, of course, there people are doing, those who are working in the environmental science, they do emission auditing. Very, very important. You can see the air quality index is monitored every day. Carbon management, another concept. Environmental stress screening is completely a reliability concept, ESS, environmental stress screening. Okay, it's only to see how much is how much amount of this harmful substance is released on this thing through reliability studies, etc. Climate models, very, very important. Various climate models are now available. So please refer to the book. Life cycle assessment, LCA. Then cleaner production assessment is done by many government institutions now. And many other assessment models are also there as a part of this assessment models, improvement models. Then there are many other models also discussed in the book. Okay, so let us talk. One of the things where I had told you that green stat is one of our contribution. So it could be defined as the systematic collection and analysis of data that could lead to assessing environmental impacts of the operations of a firm. Okay, this is where it's actually this was particular topic initiated from my own experience with the industry people. So most of the time they don't focus more on this environmental impacts of the operations they do. So they always are of the they focus only on their business profit and the business increase in the profit and increase in their business areas and products, marketability and all those issues, forgetting completely on these environmental issues. So I think we should have. So we did a project on that, and we found a lot of correlations and association between the ideas they implement and the product they bring out, and the productivity. There are a lot of correlation with the productivity and the items which they produce, if the products are really having some innovations. Okay, so it's actually a quality concept creates, which we found that purpose towards improvement of product and service to become competitive and to stay in business and to provide jobs. And this increases a common interest in achieving better goals in product and service quality, along with a long-term relationship with the firm and the customer. That's very important. So we always nowadays all products are addressed to customer. Or in fact, people say customer-focused products are made these days. Okay, so the earlier time, if you make a comparison between the products which are produced some 10 years ago and after 10 years, you can see maybe after 2000, for example, altogether there is a paradigm shift in the approach. Okay, so earlier time people, the producer, whatever he or she has, then that will be used for production. That's all. If they produce whatever they could, that's all. So they were limited to many constraints, for example. Nowadays, although they are limited, almost all producers are limited to under a lot of constraints, but because of competition, they have to produce customer-focused products. So customer-focused products, everything is now addressed to that. So this is the change happened up to 2000 and after 2000. Okay, maybe you can change the period if you want to say maybe 2010 onwards, for example, new generation things, because new generation ideas are now, and ideas are very fast and very creative. And that's where we have to come up. Okay, so all these new initiatives are coming only to generate ideas. Look at the mobile revolution, for example. Look at Samsung mobile, for example. All of us, for example, even I am also using a Samsung mobile. We know the importance of Samsung mobile. Okay, now the price variation also, but you just imagine the way the features are added every day. A lot of features are added and increased and aligned every day in the instrument, and all these are ideas rather. Nothing new to me. Actually, new ideas are implemented as features. Okay, new apps, for example, new navigation procedures, for example. Okay, moving from one window to another window, and getting the information from logically and creatively. If you think where the things are possible and where you get the things. So look at the mobile. Very high amount of innovative ideas are inbuilt. Okay, high amount of quality. Quality is also very high. You can look at that. Okay, so this is what is happening. So you need a lot of evaluations. That's very important. Green strategy is actually going to give an evaluation of every activities you perform in the firm, in the organization. Okay, and you have to monitor everything. You see how much amount you are having investing on energy, for example. That's what I want. You look at your home, for example. How much amount of energy you are using for example, a mobile, for example. Have a monitoring, have an accountability for that. See other instrument, how much amount of energy. That's the reason why the electric bill is going up. Okay, you cannot complain to the electricity board for that. My electricity bill has increased. A lot of incidents you have during last this thing. Okay, during lockdown it was almost everybody's electric bill was going up. In fact, increased because we were at home. All the instruments were on. All were under charging. Okay, just imagine, that's the reason. Anyways, I don't want to. I am not an expert to make an evaluation. I can support, I can suggest, I can find ways to reduce that. So, okay. So green strategy, a lot of issues we have studied thereafter. We have brought the issue of supply chain dynamics, then evaluation methods, methods of evaluation, then e-commerce and e-governance. It's a very good idea. It's a very good idea. There is no doubt about it. Of course, the local vendors, local stationery shop owners, they may have problem. They will definitely have problem. But in a way, they can also shift to this particular the ideas. They can also shift. Okay, see, things are changing. You cannot stop. Okay, if the computer is the importance of computer is increased, and if everybody wants to have the computer the use, then definitely you should think in that direction. You cannot stop. If you stop using that, if you don't go according to the time, definitely you will be back at the back. Okay, so e-governance and a lot of issues comes. A lot of people complained about e-commerce activities, e-governance or e-business, for example. E-business. Let me put everything in e-business. E-business, electronic business. You see, we have now paperless office now. That's a good idea. It's a lean. There's a lean concept. There's a green concept also. There's a clean concept also. Look at the offices, government offices so up to 2000, for example. Almost every office is crowded with files and books and reference materials and a lot of things. You see the amount of space it consumed. Of course, we need records. Okay, all records are important. Okay, yes, they have a space called museums where you can keep it. Okay, but office digitalization is very important. If government is promoting, definitely we should also support. We should also learn knowledge, how to digitalize, and for that you should know how to, at least to the basic operations of computer, you should know. So that's very important. Take a training for that. Okay, it's now everywhere now. All places, it's governance in education is a lot. For the last 1 year, we know. All together, there's a transitional change. All of us were online. Okay, teaching online, examination online. We got familiar with many online platforms. You see, this presentation is also happening online. Your seminar is also happening online. Just imagine this 1 year period. The virus, coronavirus, has taught us many things. It was, in fact, a blessing in disguise for all of us. I would look at from that end. Coronavirus is a blessing in disguise for all of us. Okay, that's how I look at it. Anyway, I know it's a dangerous thing. We should be very careful. If administration says that you should follow, means follow. Follow rules. That's very, very important. If you have to wear helmet, means you should wear helmet. Okay. While not wearing helmet, if you feel that, okay, you are safe, fine, you may be safe. You may think that the corona will not come to you, fine. But you can be a carrier for somebody else. Why don't you understand that? Follow the rules. That's very important. In LGC, I recommend some of the, I am going to give you some recommendations. I find that this is very important. Follow the rules. If you don't follow, if you defy the rules, problem may not come directly to you, but indirectly it is going to come to you. You are harming the environment, you are harming the people, you are harming the society, you are harming the nation, you are harming the world. Please know. Why are you putting others into problem? Okay. So there are many such interesting things and facts. I feel that, yes, again, I'm reminding you the second slide. I find everything in excess is waste. Please, we have many things. Why do we need 4 vehicles at a home? We have 4-wheelers. How many 4-wheelers are there? I'm talking about new generation. Earlier time, you see, till few years ago, nothing was there. A car used to be a luxury item. Only very few people used to have cars, a 4-wheeler in a home. Nowadays, 4-wheeler, 2 4-wheelers, and 4 or 3, at least, I think, 2-wheelers, for example. One has to go to office, one has to go to school, one has to go to college. No, all three, suppose it's a family of 4, family of 5, for example. How many mobiles you have? How many shoes you have? How many pens you have? How many TVs you have? At least 2 TVs you have at least. One is simply leaving idle, because the new generation TV you are familiar with. You want LED TV, wall-mounted TV. You want that. So what happened to the old one? It is lying simply in the office. I mean, not office, in the storeroom, because its utility is not complete. Please know. Earlier time, people used to change something only after the complete removal, or maybe the time to remove by breaking, if it is gone down or etc. completely down. That time only people used to replace or get a new one. Nowadays, nothing doing. People simply buy. How many mobiles you just imagine? How many mobiles you have? You have one at home, you have one at office. At least these 2, at least you have. Okay. You need charger also. How many chargers you have? Definitely you will have 3 or 4 chargers. Suppose even you forget to take the charger from your home to office, definitely on the way you will purchase another one. You have an excess one. Okay. Materials are lying waste. Please know, either in office or in your home. Okay. There are many other issues like reverse logistic, for example. Very, very important. Reverse logistic. We used to have logistical study related to this thing. You please imagine, just an example. We all, order for online products through online market platforms like Amazon, Flipkart, and many other platforms. Talk about everything these days, everything, because government is also promoting that kind of things. Right, that's right. Now we order more so that we feel that, okay, we can send it back. Because even if the item goes wrong, we can, because the online platform, they are also selling that, okay, we'll take it back, don't worry if you are not satisfied. Now imagine if all of us start sending back, where this item goes, all this item generally if they are delivering, definitely they deliver from the local vendors or this thing, etc., etc. Once you return, all this returned item goes to the headquarters. And headquarters, generally items goes waste. They don't have any waste to dispose. They can't do that. Even their policy, they also says that they cannot resell it. Their policy is like that. Even good branded people, definitely Amazon and Flipkart, I don't think they will resell it. Because their policy says they cannot show any quality compromise. Once they sold, means sold. Now, this is where the reverse logistics comes. So my point is the reverse logistics. Reverse. You are all selling back, sending it back, and ultimately the items goes waste. Okay, it's generating huge pile of products just like it's harming the environment. Okay, and there is another interesting topic which is coming up: reverse engineering and benchmarking concept, etc., etc. So this is all together, you can say, green statistics concept. So let us look at some promotional activities quickly, because it is already 3:30. Okay, so let us talk about quickly somewhere. So identify the use, necessity, and source of energy in each activity. Okay, you should identify what for it is. Please see the necessity of the product, necessity of the food. Okay, see the food product, for example. Do you really need parotas, for example? Do you really need pizzas, for example? Do you really the fast food, for example? Okay, even noodles, for example. Consumption of noodle is not good. Although I have given this as an example to make you understand what you mean by that. Noodles. Okay. Now, question is that, do you really need? We need 3 times food. That's fine. Morning breakfast, lunch in the daytime, and dinner in the day. In between a tea and snack, again between 2 to 4, you have another tea and snack, and plus extra. If you go to another office, you will get another tea and etc. You just imagine. You just imagine all these are going to come in form of waste. Okay, I don't want to now again give the naming of what you mean by waste. Okay, it's a waste. Okay, you can understand that what's the meaning of that. Measure and monitor the quantity of energy used. Minimum the best. Minimum the best. Incorporate renewable energy and energy efficient equipments into homes and organizations. Yes, of course you can use a lot of ways you can think of. Have own sources of waste disposal methods. Use a holistic method of manufacturing methods of sound carbon emissions. Of course, it's a very good thing. We can also go back to our olden type of coal-based cooking, for example. You can have gas instead of gas, so you can use stoves which are used. Earlier time, if I remember, we used mud also. We can use what you say, that stove which they use as chagiri and umi and all those things, etc., etc. We can use that kind also. It's a good that produces good quality of carbon. Actually, it's good for health also. It's good for quality of food also. It's good. Okay, that's what a holistic method you should use. And many often we are going back to the old traditions. Okay, many traditional things we are making it back, actually speaking, to active. Monitor and practice measurement-based evaluation interpretations. That's what I feel. I stress on green statistics. Have everything measured and count. See the average, for example. Play with mean and variance, for example. We have a very good measurement called mean for average, for example. Again, very good measurement for variation. You can use a standard deviation, etc. Make an assessment every day and see how much you are increasing, how much you are decreasing. Monitor carbon management and GHG emissions. Safeguard flora and fauna of this. Okay, use of plants, trees, etc., etc. We are harming our ecosystem biodiversity by removing this flora and fauna of our ecosystem. Flowers, plants. Okay, use it for better use. Promote multi-user transportation methods. Yes, it's very important. MRT is a good concept. You can have mass transport. Metro trail is a good concept for lean, green, clean. It's a good concept. You can transfer large amount of people in one go. Okay, continuous frequency without harming the environment. It's a good concept. Encourage the use of bicycles for short duration journeys. Of course, also walk for short duration destinations. Be content and learn to compromise with the availability of natural resources. And transform I to we. This is very, very important. Transform I to we. If that is the case, because many often we are centered on us, myself, my family. Okay, that case we are restricting our thinking process to a very narrow level. Once you have centered mind, definitely you will not look beyond. That looking beyond will automatically transfer from I to we. That we becomes now a collective thinking process. Okay, that is good for. That automatically reduces corruption also. I have my own viewpoint on reducing the corruption. I find this is how this best the way you can try it. Transform I to we. You can automatically reduce the corruption. Okay, so and sustainable activities. Let us quickly look at ensure to get green quality certification. I find that all industries, manufacturing industries especially, it can be automobile type industries also. They should definitely go for all kinds of they have the minimum level of this thing. I mean, they should go for lean, green, and clean certification. That's why my stress. Okay, they go for ISO 9000 certification and all other related this automobile. They have AI, AG kind of certification, etc. Above that, they should go for LGC certification also. I am promoting this concept now. And appraise GHG emissions importance in impact and environment. All stakeholders, tell them, please make aware. I think we should keep this also. We should educate our students also. What is the importance of GHG emissions in the atmosphere? What is the contribution of carbon dioxide in that? What is the contribution of methane in that? What is the contribution of nitrous oxide in that? How much it is going to be harmful, which is going to be best and which is going to be not best, etc. I think we should educate this kind of concept to school-going students, university-going students, etc., etc. And this is what I'm doing here in my university. I introduce this course. I'm teaching this course only to make them understand at least if I can contribute something for the society, it's good. Maintain health cards for all stakeholders for sustaining quality practice. Make a health card. We all have health-related card. This health card, I mean, for sustaining quality practices. Maintain inventories for all items, repairable or non-repairable. There are a lot of repairable and non-repairable items where you can find what is the inventory required for. Okay, if required, only then use it. Okay, please do not have excess inventory at home. Okay, you as a student, you look at how many dress materials you have. How many dress materials you have? How many of them are under use now? Very few. You are using one. You may need, okay, every day if you are changing means you need only 7 combinations, 7 pairs, shirt and this thing, etc. Instead, how many pairs of dress materials you have, which is simply lying idle, which is simply unused? Just imagine. Excess material is waste. Excess material, anything which I told you is going to be waste. Maintain dead stock items, its reuse potential and methods of its disposal as well. Please also find out, okay, if you are responsible to generate waste, then definitely you will have to find out how to dispose it as well. If that is not the case, then definitely you are harming the environment. You are creating problem for others. If you are not giving the space for others, definitely things will not grow. Okay, so please know. Today, I think I commented one thing in KSAJ group, WhatsApp group. I think you should give space for others also to speak. Okay. Declare maintenance of raw materials and other things for most frequently in use. If that's the case, use it. Maintain account of those, as I told you many times, and encourage e-business, e-logistics to save the environment. That's the best way. Avoid queues. Avoid customer grouping, avoid customer gambling, gathering, etc., etc. Okay, e-business is a very good. E-logistics, for example, wonderful concept. Integrate information technology in all day-to-day activities. Anyway, we have to live with mobiles and internet facilities now. Computer, desktop computer, or laptop computers, very common and everywhere. And in Kerala, they have already started distributing this thing on installment. Now everybody is anyway going to have this, so use the best use of information technology. Promote internet usage for all kinds of information-based things, etc. And please also take a note. Rio 20+ Unique Summit held in June 2012 stressed that every organization should strive for continuous value enhancement for the whole of society. And one should focus on these developments that meet the needs of present without compromising future generations' ability to meet their own needs. And this is the real sustainable development. So quickly, let me put the quality of life also in one or two things. So what is the meaning of quality of life? The concept of quality of life was popularized by world bodies like UNDP and WHO in measuring improvement in the status of living conditions of people belonging to the developing countries as against those of the developed countries. Okay. So this is how the quality of life, the promotion has come, UNDP, and the latest in this wagon to join is the Sustainable Development Goals, the 17 Sustainable Development Goals. I'm sure many of you are familiar with that kind of things. So there also quality of life is stressed on in very many ways. Quality above life, that's one of the components, is quality above water, quality above water or something like that. And quality of life is broadly defined as an individual's happiness or satisfaction with life and environment, including needs and desires, aspirations, lifestyle preferences, and other tangible and intangible factors that determine one's overall well-being. This is how we have to look at quality of life. It should not be self-centered. It should not be centered on I. It should be centered on we. Okay, look at the environment. Look at your society. Look at the climate. Look at the biodiversity. Okay, only then you can say that you are living in it. Because the air you breathe, the water you drink, all should be quality. The water, the quality which you are using nowadays, we are using distillery type water, purified water, RO system water. See, the transitional change happened over the last few years. Okay, our parents, for example, what kind of water, what kind of food they had very shabby, filthy, and this kind of things, and still their immunity was good. Probably that is the reason why our immunity is also good. Okay, we are the breed of them. So way ahead, we have to see, look at from that. If happiness is the sole objective of living a quality life, then such a thing should come from the acceptance of society and the world around you. And being simple, humble, and flexible makes you understand your people and ecosystem more, and you become committed to sharing the tenets of your joy with everyone around. Please understand. Okay, if you want to have a sharing, make a habit of sharing, make a practice of sharing. Okay, you know how to share. You may share with family, for example, but the sharing, make a habit. We have seen many examples we have seen during the calamities and natural problems, and we had in Kerala also. Okay, make a habit. Okay, be simple, humble, and flexible for. Okay, it makes you more responsible, confident, and mentally balanced. And one should strive for the betterment of the people by being concerned is the best way of leading a quality life. So this is where, and these characters automatically qualify for a good human being. Okay, so this is my point of this thing. And there are some recommendations I told you. There are many recommendations I have given, but here are few which I just wanted to share. So prepare a mission statement for your life. What you want to do? Be grateful to all natural resources and its blessings. Okay, whatever we have is all due to the blessings. Okay, you can consider blessings from where? Okay, I would say from the climate, from the Mother Earth, for example. Okay, everything. Maybe you can say even God also. I don't know. You can say that. Let the environment and society be part of your life's priority list. Keep this also in your priority. You have many priorities personal. Keep this also in your priority list. Do not miss any opportunities, challenges for any improvement. If you have any chance to improvement, please do that.
Hello.
Do not miss any. Yes.
Murali sir, we are running short of time.
Okay, I'm just.
Do you conclude the speech?
Okay, I'm concluding. Okay.
Yeah.
I'm concluding.
Yeah.
So accept everything as a blessing, respect time and value others, etc. And finally, here is the note. So the reality today is that we are all independent and have to coexist on this small planet. Therefore, the only sensible, intelligent way of resolving differences and clashes of interest, whether between individual nations, through dialogue. Very, very, very important. I think there is a dire need of dialogue in Kerala for the ongoing strike. Okay, so please. Anyway, I am not a politician. I am not making any political comment. Just I found that it's very, very interesting, very relevant for the situation. Any questions? Thank you very much. These are my books, okay, which already published, but the book which the presentation where I based is going to come very soon. I will share that also. I hope this you are familiar with. So Six Sigma for Organization, some of the presentations, some of the things were inspired from my first book. Okay, this is published by Springer. So please have a look. Thank you very much. Thank you. Over to you.
Thanks for your nice presentation. We are always looking forward for your new book publishing very soon.
Thank you very much. Thank you very much.
I think there will be any questions. The organizer or Gautami will intimate us for the time.
Thank you. Thank you. Now, I will also request all the participants, if they are interested, please, they can communicate me online. They can also call me. My phone number, everything is available online. All my details, all my papers, around hundreds of my papers are available on ResearchGate, Google Scholar, etc., platforms. So yeah. I would also like to see people whether they are interested in this kind of work or not. I am also interested to know that kind of. So thank you very much.
Yeah, okay, that's good. Now it is throwing a light to a very innovative idea and as well as an innovative area. That is a very old insight. I will incur very good insight to all of the participants here. And
Thank you.
I am thanking you personally as well as for the coordinators. And I am also thankful for your sparing of your valuable time for an
Thank you very much.
invited. Thank you.
Thank you very much. Yes.
Yeah, thanks.
Thank you so much, sir. I would like to
Thank you.
extend our gratitude to Muralidharan sir, Satheesh Kumar sir, and I would like to thank Xavier sir for chairing the session. Thank you so much once again. So here we come to an end of the first day of national webinar on the recent developments in statistics and probability. We will resume our next day sessions by sharp 10 a.m. So I request all to be present in time. Thank you so much.